This
We're
conference
going
will
to
now
do
be
this.
recorded.
We're going to do this session, and then we'll have a short break, and then we'll take on the second 2-hour session tonight as well. So without further ado, Tom, you are up. If you could introduce yourself and give a little background, it's
Dave's
all
gonna,
yours.
Dave's
I
gonna,
think
I
I'm
think Dave's
supposed
going to do that for you.
I guess.
go, Dave.
All right, Tom, you ready to go?
I'm ready.
All right, I'll let Tom do most of his introduction for you, but Tom Lahan is a longtime home inspector from the Kansas City area, and I kind of lost track. You and I have probably known each other for, I don't know, what, 25 years?
Yeah, too long.
Yeah, it is too long. But been a long time ASHI member. He has, and again, I'll let him go through his introduction. Tom has a school out in that area, in the Kansas City area, where he's been teaching home inspectors to get into the business there, just as I've been doing here. So I'll go ahead, Tom, and let you get started with everything. And Neil, if you want to go ahead, I guess, and mute everybody.
Okay, well, thank you, New Jersey, for allowing me to speak this evening. And I have to forewarn you, this is my first virtual seminar, and I usually work best with interaction. And so it might get a little interesting since I'm talking and don't know whether or not you guys are understanding or getting what I'm saying. But if you have questions, send them to the chat, and during break, I'll answer as many as possible. And if I can manage to get done with this segment a little early, that'll give us even more time to answer questions. Okay, I've been in business since '89, teaching since '93, been ASHI since '92. I'm also a ICC code inspector, and I sub out to cities now and then when somebody goes on vacation or they got something commercial and they don't feel they're qualified. Let's see, enough of me. I've been around a long time. Let's talk about vinyl siding. Vinyl siding has been around for a long time, and it was first used in the 50s, but then by the 70s, it was head and head with aluminum siding and ahead of steel siding. In the early 80s, in most markets, it became the siding of choice, even over wood and fiberboard, especially due to the failures that the fiberboard was experiencing. That gave them a big heads up. By 1995, it surpassed both wood and any other siding material as the material of choice. And that covered 30% of the new construction market and virtually 95% of the residing market. So they had a huge market share. The advantages of vinyl siding, especially over steel or aluminum, is the color goes all the way through instead of just on the surface. For instance, steel has a problem with paint peeling after about 15, 20 years, whereas the color in the vinyl will fade a little. If you've got a really dark color, it'll fade a lot, but at least it doesn't peel off. One of the other advantages of vinyl is minor hail damage, hail impacts very rarely will show. It takes a pretty good size stone to crack it. So vinyl, in relation to temperature changes, does not make the loud popping sounds that metal siding will make. It doesn't conduct electricity, so there's no grounding or bonding needed to bond the siding material to the electrical system. And it doesn't amplify or transmit the sound of rain or hail nearly as much as, again, the metal siding. It doesn't peel, rust, pit, corrode, the surface doesn't flake away since it goes all the way through the material. And since the 80s, it's had a big price advantage over aluminum and steel. Now, I don't know in your area, but in the Midwest, virtually nobody uses steel or aluminum siding anymore. And vinyl is, unfortunately, in my view, the product of choice for residing. My preference would be for them to take care of the siding they've got and leave it there. Okay, the disadvantages of vinyl siding. Everything has a disadvantage. It's the expansion and contraction. And with that issue, if it's not installed correctly, it does present some problems that we'll go over. Discoloration means it fades a little bit. The lighter colors fade a lot less than the darker colors. And in sub-zero temperatures, it does get brittle. And for instance, 2 weeks ago, we had minus 20 degrees. And if somebody had gone out and probably did much more than tap their vinyl siding, it probably would have shattered. So that is a disadvantage if you live in a really cold climate. So what is it made of? 80% polymers and 20% of the other ingredients is what gives the color, gives the vinyl color, gloss, temperature, impact resistance, flexibility, and durability. But 80% is nothing more than PVC, just like pipe. Expansion and contraction is a big issue if it's not installed right, and it's all related to the outdoor temperature. As the temperature approaches 100 degrees, a 12-foot strip will stretch a half an inch, and virtually the same thing in shrinkage when it gets cold. They now have a form-fitted foam insulation that is installed right with the vinyl siding itself. And that has helped a lot in so far as it's much better insulation than the 1/4 inch fan fold insulation. And two, since it is form fitting, there's no void, no measurable void. So when hail hits it, even a good size hail, the foam will absorb the hit and let it bounce off before it'll crack it. So that's a good advantage. So my mouse gets a little carried away. Okay, so the wall preparation. It can be installed over open framing, but as far as I know, nobody's done that in the last 20 or 30 years. So the substrate materials that are being used today, obviously the oriented strand board, the plywood, some people are installing it over 3/4 inch or inch thick foam boards. And then you can also use the fibered sheathing. You have to keep planar irregularity to a minimum. Like in EIFS and stucco, for instance, the substrate can't have more than a 1/4 inch variation in any direction, 8 foot. So it needs to stay pretty flat or it will telegraph irregularities in the siding. House wrap or felt paper. Until 2006, the code book did not require felt or house wrap. And the Vinyl Siding Institute, who is the organization for vinyl manufacturers, on their first page, it says, this is not a watertight material and must have house wrap or felt paper behind it to prevent moisture entry. And you can tell that the vinyl siding is not designed to be watertight. Otherwise, they wouldn't have little drilled holes in the bottom of the channel to drain out water. But literally until 2006, the CODE book did not require it. And sorry, occasionally you're going to hear me spell CODE because in home inspection class, you don't want to use that word. So I spell the word instead of saying it. So just play along with me on that. Oops, now I'm going backwards. All right, 2006 is when the water barrier was required since vinyl is not watertight. The picture of the building you're looking at is a building I looked at in Providence, Rhode Island. They had 156 units and they were all installed the same way. They had the house wrap on it, but they terminated it at the window, didn't fold it into the window, and none of the windows had the flexible flashing, the vinyl tape. So they got water in all 156 units and the clubhouse as pictured here. And it's really kind of difficult to see, but right down here at the bottom of the lower windows, you can see the OSB board is rotted right at the corners of all the windows. So that was an expensive fix. Tools of the trade. Other than the hammer and a saw to cut the panels, there's 3 specific tools. The nail slot punch pictured on the left is used where you're going to cut off the nail strip, which is up here. Let's say you're cutting it off across here, but you need to nail it. You need this to punch the hole for the nail. The snap lock punch is this critter, and if you're going to cut off the vinyl strip in this area and tuck it into a J channel or the lock on another strip above it, this tool is used to punch a little dimple so that the J channel or the strip above it can catch it. I'll show you a better picture of what it looks like here in a minute. And then if you have to replace a strip for some reason, most likely damage, this tool is called a zip tool. You insert it in the lock on the underside, pull down, and it snaps loose, which makes it easy to replace the individual strip. So the fasteners that you're going to use have got to be either galvanized or some type of corrosion resistant material. They have to be a minimum of 3 inches long, plus the thickness of the substrate. So in other words, if you've got a 1/2 inch OSB board, they want you to use 1 1/4 inch nails, or fasteners, I should say, so that it penetrates not only any foam that you've got behind it, but also penetrates the substrate material. And then the head diameter needs to be 3/8. So the best, if you're going to use nails, the best nail to use is a roofing nail because it has a nice big head on it. And then you can use self-tapping screws. They have to be a minimum of 1 1/8 inch thick. And then the head has to be a minimum of 3/8 inch. So you got to watch that closely because the majority of screws on the market are not quite 3/8 inch. The heads need to be that 3/8 inch diameter so that the nail or fastener won't pull through the nail slot. Staples is another acceptable method of fastening the siding if it's approved by the manufacturer. So if you're going to use it, it's got to be 16 gauge nail. It's got, 16 gauge wire. The crown has to be a minimum of 7/16 inch wide and then long enough to penetrate the substrate 3/4 inch. So conventional nailing or staples would look as it's pictured here. The nail or the staple must, quote unquote, must be inserted at the center of the slot. It's inserted at the center so that as weather changes, the vinyl can stretch and shrink. If you nail at one end and it tries to shrink, it's going to tear the nail fin, and then the nail head or staple will pull through, and then you get a big bulge in the side of your structure. You've probably seen that issue going down the street where it looks like the siding is coming loose from the side of the building. Well, it's because they secured the vinyl siding too tight. So when you're doing your inspection, any strip of siding that you walk up to should be able to slide either direction, say 1/4 inch. If it will not slide, then it's secured too tightly, and you need to make sure you write that up, because it'll either tear the nailing fin or you'll get oil canning, which is a ripple in the siding material. So be sure that you test for movement. Now you can install vinyl siding either horizontally or vertically. Now on this last slide, I just said that you had to put the nail in the center of the slot. If you're going to install it vertically, the top nail on the panel goes tight against the top of the first slot. And then the rest of the nails going down the siding would be in the center of the slot. The top nail goes tight against the top of the oval shape so that it can slide up and down. If you put it in the center, then it's just going to slide down that 1/4 inch. You put it in the top so that it will allow for the shrinkage or stretching due to weather. But again, it's all got to be nailed loosely. So here's a picture of a combination of both horizontal and vertical. It gives a pretty good appearance. Okay, so now to install horizontal strip siding, very first thing that happens is you put on the starter strip at the base of the wall, then install the window flashings and J-channels, door and window trim, the corner posts, gable end J-channels, and then you start installing the vinyl strips. So we'll go through some of these steps. The bottom course is inserted in the corner post and then applied upward as you install the strips. The starter strip in the market today is plastic. It used to be metal, but it has 2 different nail slots, and depending on the clearance from the bottom of the substrate will determine whether you have to use the upper or the lower slot for your fasteners. The bottom of the starter strip should be installed at a minimum of a 1/2 inch below the substrate, and you do that so that there's no chance that water that gets into that slot at the bottom of the channel or the lock at the bottom of the strip can transfer the moisture to the substrate material. But be sure, just like the vinyl siding, be sure that the starter strip can slide back and forth. My mouse is going nuts on me. Okay, so as a result of temperature change, most all construction materials shrink and swell. The horizontal strip allowances at the corners of the building. When you insert the strip into the corner channel, you leave 1/4 inch at both ends of the structure to accommodate the shrink and swelling. So if the temperature is above 40 degrees on the day of installation, you cut it 1/4 inch short at both ends. If the temperature is below 40 degrees, you cut it 3/8 of an inch short, because it's already, the material is already shrinking. So the gap is going to be a little bit larger so that when it gets up above 40, it'll actually stretch back into the groove at both ends of the building. So once the strip is snapped into place, you nail from the center of the strip. Most strips are 12 foot long. So put your first nail in the center of the strip, in the center of the nail fin slot, and then spacing your fasteners no more than 16 inch going both directions. The nail head needs to be 1/16 to 1/8 inch from the nail fin. In other words, we do not fasten it tight, because each strip has got to be able to slide back and forth. And the nail head should never protrude past the locking hem. For best appearance on the siding, unless it's seamless siding, you're going to have slots. You're going to have exposed edges. So for appearance wise, let's say this is the front of the house. The strip from the front of the house needs to overlap the strip going to the back of the house. That way, when you're standing in front of the house looking at the siding, you won't see all these dead ends. If this was the front of the house and this strip was tucked under, when you're standing in front, you'd be able to see all these butt ends, which is kind of distractive. So when you're putting on your strips, you want to separate the joints at least every other course, preferably every third course. Avoid putting joints immediately above a window or door. Same with below the window. Put a strip that extends beyond both ends. And then offset all the end joints by a minimum of 3 feet. But whatever pattern you select, don't vary it. So in other words, if you're going to start at the bottom and the second strip is going to have a 3-foot offset, you need to stick with that 3-foot offset the rest of the way up the wall. If you stagger it and you're standing on the back side of the house and look forward, it'll really look weird, especially if they're lined up. Okay, so now we've got to talk about how we're going to start putting the flashing around our windows. Okay, the flashing is required even if you have the brick mold around the window, and the flashing that you're going to use is a J channel. The flashing is longer than the ends of the vertical. So on this horizontal strip that we're looking at here, this horizontal strip needs to extend to the outside edge of the nailing fin on the vertical. The lower horizontal portion of that fin needs to be cut at both sides, and then take this portion, the horizontal portion that you just cut, and fold it down so that it fits inside the vertical J channel. That way, water that collects above the window will run down and into this J channel rather than run down behind the J channel and between the brick mold of the window. Again, that's just another attempt at keeping the water out of the, or from getting behind the window. So now the way to insert the window and your tape flashing, you wrap the house, cut a slot at 45-degree angles at both corners of the window, tape it up so that that flap stays out of your way, and then we're going to install the tape flashing. Install it horizontally across the bottom first, covering the nailing fin if it's a vinyl window, and extend it a minimum of 4 inches out beyond both sides of the window so that the vertical piece that you're going to install next goes over the top of the lower flashing tape. If you're going to install vinyl windows with a nailing fin on new construction, you have the house wrap tucked into the window frame, but you're going to caulk the back side of the nailing fin literally right to the house wrap, again, to protect or prevent water from entering into the window opening itself. Now we're going to insert the vertical legs of the flashing tape, and they extend beyond the bottom of the horizontal flashing tape and go 4 inches above the window opening. Then we're going to put in the top piece of head flashing. Again, we extend it beyond the vertical legs of the flashing. And then last, we're going to take that top flap, fold it back down over the top of the flashing tape. This way it's the house wrap is shingled fashion over the top of the newly installed flashing tape. Then after you've folded it down, then we're going to take manufacturer approved tape and seal the 45-degree angle cuts. Now we're going to add our J channels around the windows that I talked about earlier. Again, you're going to install it in the same fashion. The bottom horizontal strip goes on first, then you go up the sides of the windows and then across the top. But remember to fold that end of the horizontal above the window over the vertical J channel, again to channel the water. Now there's a difference in opinion as to whether or not this horizontal above and below the window, the front side of the J, whether you miter it or you extend it all the way out to the outside edge. That's merely a cosmetic issue for the installer to determine. Either end will work fine. Now the ends of the strips, you butt them up against each other, but in reality, the vinyl is cut 1 inch longer than the piece that would butt up together. And that's so that there's a minimum of 1 inch overlap when these two are butted up together. Again, that helps moisture from getting in horizontally, because then it's always going to have a minimum of a 1 inch overlap. So wind-driven rain might get in, but with a little bit of luck, it's going to fall into the bottom channel here and fall out the drilled holes. Or worst case scenario is to run down the house wrap that you installed behind the vinyl. Okay, so now installing the horizontal flashing around the window, you're going to hold the panel in place, measure and mark the strip with a 1/2 inch to 3/8 inch gap at both ends of the window. You can see where here they've got it measured and shows a 1/4 inch. This is going to allow for the expansion and contraction. And then when you install the strip has to have that 1/4 inch gap on both ends so that it can stretch and shrink without bumping into the J flashing. Or some windows come with a flashing installed. So in other words, it's got a pocket built into the face of the window. But either way, we've got to have a 1/4 inch horizontally, and you want a 1/4 inch vertical. Either way, the vertical flashing or the horizontal flashing is going to cover the cut edges. So just use a 10 snip for the vertical cut to make this cut, and then a box knife or a saw to make the horizontal cut. Box knife works fine. You take one strip, one slice across it, and then fold back and forth, and it usually snaps right off. Now, installing under the window is a little trickier. Depending on how much of the strip you have to remove under the window would determine whether you would use a J channel with a utility trim or a dual undersill trim. This just requires 2 pieces to be installed by the installer, whereas this is manufactured as 1 piece with 2 catches on the 1 piece. This is the J channel with a utility trim installed. So if you have to cut off a lot of the top of the strip, the horizontal strip, you're going to insert it in between the utility and the J channel. If you're only cutting off a little bit of the top, just say a little bit more than the nailing fin, you install it in the backside of the dual channel. Now the logic here is the shadow line will look weird if you cut off a whole lot of it and stick it in the back side. So if you cut off a whole lot of it, you put it in the front side, and then the slope of the angle doesn't look weird when you're looking at it from the front side of the street. So if the horizontal cut is near the butt of the strip, use the outer channel of the dual underside trim. When you get to the top of the window, you're going to do virtually the same cut measurement so that you've got a 1/4 inch on both sides so that the strip will move horizontally. Now, when we get to the gable end of the house, you have, you've got to make a angled cut. So the easiest way to figure out how to make that angled cut look right and fit tight is to take your horizontal strip and butt it up against the J channel in the groove. Then take another strip and just a piece that's left over and insert it into the J channel. And that will give you the exact angle you need to cut to get this strip to fit neatly into the J channel. And the first time I put up vinyl siding on one of my rental houses, I didn't know how to do that. And I had a heck of a time getting that cut to lay correctly. Then I read the instructions. Typical guy, right? So now when you install these strips on that gable end, you're going to get up to the top. And once you get to the top of the wall, there's no nailing fin. So this is one of 2 locations in vinyl siding where you're allowed to have face nailing. But before you put that face nail in, you have to take the nail punch that I showed you earlier and punch a hole. It's a vertical slot type hole so that the vinyl, even though it's a small sheet, it will be able to move. So the upper strip doesn't have the nailing fin, but you still use a 1 1/4 to 1 1/2 inch long nail. And obviously you want the head of the nail painted to match so that it looks correct. Roofing clearances. Now most siding manufacturers require anywhere from 1 to 2 inches of clearance. So you should be able to see 1 to 2 inches of the vertical leg of your step flashing. Well, the Vinyl Siding Institute only requires a 1/2 inch of vertical clearance. I never called them to ask them why only a 1/2 inch, but that's what the manufacturer says. So that's what we expect to see. Incidentally, this VSI, everybody, if you're taking notes, you ought to write down VSI. It's a Vinyl Siding Institute. You can go to vinylsiding.org and they have printed out a PDF of the full set of instructions on how to install vinyl siding under any conditions. So that would be a good piece of information to have when you're writing up a report that shows where you have seen installation defects. That way it's not just your opinion. You've got something to back it up. Okay, J channel at the intersecting roof line should be metal if you have south or west exposures due to the excessive heat. In the Midwest, everybody uses the vinyl, and I haven't run into any deterioration due to the heat. So in your particular area, you just have to take it as you see it. And if the J channel is deteriorated or warping because of heat, then they should replace it with the metal. And if you're going to use metal, you want to raise that channel even more so. So instead of just the 1/2 inch, you want to go a little bit higher than that. And okay, so now we're under the soffit. Under the soffit, you're going to use a J channel again. The uppermost strip will fit right into the J channel, but 99.9% of the time, you're going to have to cut it to fit the distance. The J channel, again, will hide the 1/4 inch short that you cut that strip. So you measure from the lock on the piece below to the top of the J channel, measure down 1/4 inch, and that's the distance that you cut your strip to. Mark the strip to be installed, score it, and then bend it back and forth until it snaps off. That's much easier than using the tin snips. Okay, I talked about the snap lock tool creating a catch for the lock to grab hold of. So instead of cutting the piece off, it creates a fishhook effect, and then the fishhook effect catches on the J channel or the vinyl strip above it. So when you're going to cut your notch, the notch as it's being cut needs to be a little more than 1/4 inch from the top edge of the strip, so that you have at least 1/4 inch above the lock. And again, we're looking at shrinking and swelling issues. Push the top edge into the undersill trim or the J channel, and then those tabs that stick out will catch on the lock and hold it in place. Now, a soffit can be installed either ventilated or solid. Obviously, this one is ventilated. And if you're going to use the ventilated, and this is a residing, something that is very important to keep track of is, are these holes lined up under the perforation? I'm sorry, are these perforations lined up with the hole that was cut in the soffit board so that you actually have airflow going through? But before we install the strips, we've got to install the inverted J channels. You put an inverted J channel at the outside behind the fascia board and up against the substrate material, and secure it every 16 inches. And then at the ends, both ends of the J channels, you want to measure the wall to the inside edge of the fascia, then subtract 1/2 inch. Excuse me, that might have been confusing. So let me rephrase. When you've got the J channel in place, the strip that you're going to install needs to be cut 1/2 inch short of the measurement tight inside J channel to tight inside J channel, again, so that it'll slide back and forth. Now, most soffits, at least in my part of the country, are 16-inch overhangs. As a result, the vinyl will span 16-inch without noticeable sagging. If you're in an area where you have 24 or more inch soffit areas, you have to put in a nailing strip, or if you have an existing soffit board, you nail at the center of the span to prevent sagging. 16-inch will span, 24-inch will sag. So again, in the center of the slot, towards the center of the strip in this area, you're going to put one nail, and again in the center of the slot, and these obviously should be able to slide back and forth. Here's what I've found on more than one house where they added the vinyl siding after the fact. And when they vinyl sided or installed the vinyl for the soffit, they didn't bother to take the grill off of the existing soffit vent. Since we're talking about soffit vents, a metal vent, a metal soffit will only allow 40% of its square inches to be net free vent area. If you're going to use partially slotted vent for the soffit, not only does it have to be over the top of the hole, but as it's seen in this photo here, this will not accommodate a hole that's cut 8 by 16 in the soffit this way. So you should never use the perforated occasional perforation strips. You need to virtually use full slot strip. Otherwise, you're not going to have adequate attic ventilation. So that's something to look for, especially on re-side jobs. Okay, the soffit can be installed with the venting slots or solid, but if you're going to make it solid, you've got to accommodate some way to have your adequate ventilation for the attic. Whoops, go the wrong direction. Okay, installing lights or any other fixture on the house. You're not supposed to take the coach light next to the front door and just slap it up against the vinyl siding, because when you screw it down, you're going to deform the vinyl siding, and then unless you have drilled appropriate size holes, you're not going to be able to slide it back and forth, and the light fixture will be loose against the wall if you can slide it back and forth. So it's best to install light blocks. Now you can use the same light block for the outlet, for the light fixture, for the hose bib, but you should not go through the vinyl siding strip for any of those attachments or penetrations. Gutters, Sutters, yeah, I've got a spelling error. Gutters, downspouts installation. The securing fasteners need to have holes drilled 3 times the diameter of the fastener. So if you're going to use that roofing nail and you're going to drill a hole, you don't just drill a hole the size of the nail, you drill a hole 3 times that size. And that's so that not only will the strip slide back and forth, it will also slide up and down to accommodate the temperature change. Apply sealant around the fastener so that as you nail it through the vinyl and the house wrap, it creates a seal at the house wrap so that moisture can't get in. But always keep in mind the siding needs to be movable, so it has got to slide back and forth. You know, it's always good to have the owner with you when you're doing your inspection. On this particular house, I was doing my wrap up and I said, so is there any areas of the house that we haven't looked at to your satisfaction? And he came back and said, well, yeah, I'm kind of worried about that piece of vinyl that's pulling off of the house. I didn't catch it. So we walked around the corner and he showed it to me and I said, yep, that's why I brought you along, so that I wouldn't miss anything. I had to add a little bit of humor to my error. So what you need to watch for is the good old gutter guy. He didn't use a fastener for that strap around the downspout. He didn't use a fastener long enough to get through the foam that was installed behind the vinyl and into the substrate and through the substrate. So shortly after he installed it, it just popped the vinyl loose from the overlap, and I'm bad, but I'm glad he caught it, so I didn't get a call after the fact. Warranty on vinyl siding material is iffy at best. It does come with the materials only warranty for the life of the original owner, but transferability varies widely by manufacturer. So if someone is putting new vinyl siding on a house to satisfy the real estate transaction, you want to make sure that the ownership papers that go back to the manufacturer is in the name of the new owner, not the seller. Most manufacturers cover peeling, flaking, rust, blistering, corrosion, and some manufacturers on their high-end materials will cover color and gloss and hail damage. But if, again, this vinyl siding is being installed for the transaction, be sure they get a copy of the warranty in addition to the ownership. Fading does happen. There's no way to escape it. And unfortunately, fading is not uniform. So on this particular house, you can see where this was the original color. This bundle faded more so than this bundle, and this strip was just a leftover piece from this bundle. Again, according to the manufacturer, some manufacturers cover fading, some don't. Window-related reflectivity. I've seen it happen, and the double pane window of the house next door reflects the sunlight against the vinyl, and it literally cooked the vinyl siding. But not only will window glass do that, swimming pool water will do it. I haven't seen it, but I understand that patios that have a high gloss sealant applied over the top will reflect it. And somebody even told me that an asphalt parking lot has caused it in some instances. It's not our job as home inspectors to determine what caused it, but we have to make sure that you write it up. This is just a photo or a diagram that I took from Ernest Orlando Lawrence Berkeley National Laboratory report in 2011 that showed the sun at various angles hitting a window and then reflecting the solar energy against the house next door. So it is a real issue. I don't know how prevalent it is up in your area, but it does happen. That was not sunlight. That's the grill. They got it standing too close to the vinyl siding, and on the back of the gas grills, there's an open slot, and heat escapes and literally cooks the vinyl. So when you look at that, you can say, well, if your steaks are done, the vinyl is too. Strips that come loose. Again, that's a common problem. And on this particular case, it wasn't the nailing strip. It was when they installed that strip, they didn't get it locked tight against the strip below it. Once you lock it, you pull it up gently before you put in your fasteners into the nailing fin above. So this one, it could have been that it wasn't pulled up tight. It could have been wind damage. It could have been that the strips below were loose and it flapped back and forth in the breeze and then it just happened to pop loose on this strip. Now, the reason this panel down here would have flopped back and forth, if you want to call it that, is the nails were in too tight, tore the nailing strip, and then that allowed 2 or 3 courses to move in the wind, and it can pop loose. Here it's popped loose, and again, it's really difficult to tell, but since it's more or less in a protected area, my guess is that the vinyl was not pulled up tight in the locking hem, and or when they cut the nailing fin off to tuck it in this J channel above, it was not cut with that 1/4 inch gap. And so when it swelled up, it didn't have anywhere to swell this direction. So it swelled in the downward direction and popped the lock loose. Hail damage. Some manufacturers will allow or cover hail damage. Most will not, but you need to make sure you include that in your inspection report if there is hail damage. Another one that causes similar tears in the vinyl is a house that happens to be along the fairway at a golf course. The golf ball can hit it, and if it doesn't have the form-fitted foam behind the vinyl siding, it will depress as it is struck and sometimes crack it. On another note, I did a EIFS inspection down at a golf course in Wichita, Kansas. And the guy says, I don't know what's going on, but I got holes in my siding material. And so I said, okay, well, let's take a look. You know, it could be woodpeckers, could be all, you know, several different things. Went up to the side of his house, and he must have had 10 holes in the side of his house from golf balls hitting it. And as we walked away, I went around to the other side of the house, and the neighbor's house had the golf ball still stuck in the siding of his house. So a little off topic, but hail is not the only thing that will damage vinyl siding. Bumping into it on the lower side of the house with the lawnmower destroys it. A weed eater can destroy it. Any of those conditions are obviously not covered with warranty, and you do need to write them up, discuss them in some way or another. Moisture issues. Everybody knows that moss grows on the north side of the house, but the question is, why is it growing there in the first place? And it's debatable. We're going to be finished with this section way early, so I hope we can have a little bit of discussion about it. I have found several houses that the attic wall behind the vinyl does not have house wrap, because house wrap is not required on a wall with uninhabitable spaces. So this one house I did, the water that came down like it's coming down here came down right at the floor level of the attic. And my best guess after I got into the attic was that they had so much humidity in the attic, it couldn't get out due to lack of ventilation. The humidity went through the OSB board substrate and then ran down the back of the vinyl siding and then leaked out into the facing of the vinyl. On this one, we'll talk about it in the chat because it has moisture coming out in various locations at various elevations. So I'm hoping that maybe someone on your end has got a good explanation. Again, this one, I did not pull a strip off to see if it had house wrap. It was a new enough house that it should have had house wrap. But the moisture is coming through at what looks like it may be floor level, just below floor level along this line. But up here, this is in the middle of the wall, and the attic doesn't start until way up here. So is it possible that the humidity issue in the attic is running down the house wrap and then finally accumulating to enough of a liquid that it comes through at seams or through the little drain holes that are established in the vinyl siding? Oil canning. It's kind of hard to see in this picture, but you can barely see waves all the way across the vinyl siding. The result of thin material, incorrect fastening, which is not allowing for the expansion. The processed vinyl is exposed to high temperatures. Vinyl is formed with that bonded foam. This is a potential issue with the new style vinyl that has that form-fitted foam. I haven't seen it yet, but the manufacturer says that that can cause oil canning in extreme cases. And then the deeper the profile, in other words, the shadow line, the deeper it is, it minimizes the possibility of that oil canning look. So the newer vinyl siding that we were talking about with the form-fitted foam, since it's form-fitted, the vinyl siding is not supposed to stretch and shrink during the weather change as much as it is without the without the foam being fitted. But then the oil canning still is a potential issue with extreme heat areas. Again, the warranty doesn't cover failure from not following the manufacturer's installation instructions. It doesn't cover oil canning, melting, whether it's from your neighbor's window or your gas grill, strips that blow off. The problem isn't the vinyl. The problem is an installation issue. And then water intrusion. Water intrusion should not be an issue, assuming it has the house wrap behind it. And remember, they have holes drilled in the bottom of the strips so that water can bleed out. And then physical damage is not covered. So let's talk about doing some maintenance and repairs to vinyl siding. So vinyl siding is not maintenance free. You got to clean it just like you would any other siding material. Cleaning it with a soft bristle brush and a garden hose is usually all it takes. And stubborn staining requires common household cleaning detergents, 1 to 10 part bleach solution, or TSP, if you can still get it up in your area, are good cleaning materials. And then the manufacturer sells their own brands of cleaning materials. Any one of those three should handle the issue. Now, when you get to the siding that has that moss growing on the side of the structure, that's going to require some additional steps. You can spray it with the household cleaning materials that we talked about, and after about 30 minutes, some or most of it should start to turn black. Once it's turned black, then you can take a brush and brush it off. If it's been there for quite a while, you're going to have to use a really stiff bristle brush and may have to do it to do the cleaning materials 2 or 3 times before you get back to the vinyl siding. But the manufacturer has cleaning products, and I'm sure that they have even more expertise on methods of cleaning your vinyl. So now when you've got buckled siding at a floor joist, buckled siding at a floor joist. So now why on earth would we have buckled siding at the floor joist? Well, on older construction where they weren't using I-joist and manufactured lumber for a rim, they were using real 2x4s. Ooh, I shouldn't say it that way. Let's see, nominal cut 2x4s, which is a little over 1.5 by a little bit less than on the rim. It'd be a 2x10, so it'd be 9.5, 9.25. Well, when the lumber comes from the yard, it comes to the job site at 19% moisture content. And the first drying season, which is the heating season in the house, the lumber dries out to somewhere between 8 to 10% moisture content. If you take a stud, 92 5/8 inch tall, and cure it down to 9%, that 92 5/8 is only going to shrink lengthwise by less than 1/8 of an inch. However, if you take a 2x10 laid on its side, is 9.25 to 9.5 inch, it can shrink almost another 1/4 of an inch. So the buckle in the siding at the floor joist is usually the result of the rim joist and floor joist shrinkage, and the vinyl will not shrink. So it creates a buckle or a bulge in this strip. In this strip, it will create a bulge, and if it shrinks enough, if it shrinks enough, it will come detached from the lock from the strip below it. So we use it or repair it by using a metal starter strip. Use the Ziploc tool to unlock it. Install a starter strip. Now here we go. Invert a starter strip into the receiving lock. Mark the overlying strip where the lower panel meets the starter strip, and then cut the starter strip, saving the locking edge portion. Insert the saved portion of the starter strip into the lock of the lower panel, and then pull the upper panel down, and then use the Ziploc tool to engage the bottom of the starter strip. Well, let's back up one. So this J channel on the bottom of this strip is now 1/4 to 1/2 inch below where it needs to be. The wind will catch it and fold it up and blow it away. So take the starter strip, just as you would use at the bottom of the wall, invert it and set it into the channel. Mark how much of this strip would need to be removed. Remove that much, and then take this portion and shoot it up into the receiver of the starter strip. So when you're going to nail the starter strip to the wall, this channel is loose. So just pull it up, nail the starter strip in place, take this strip, insert it into the starter strip, and then this piece, using the same tool, pull it down and flip it back into the starter channel or the starter strip. Sound a little confusing, but when you're seeing it done, it makes perfect sense. So here's a better picture of it. We took the starter strip upside down, measured the distance, cut this lower strip accordingly, and then shoved it up behind this strip after we cut off the excess, and it catches on this little angle right there and holds it in place. Replacing damaged corner posts. Let me just, well, I'll read it and then I'll show you. Cut off the face portion of the damaged corner post with a utility knife. Remove the nailing flange from the replacement corner post, and then insert the in place and pop rivet the new corner receiver channels together. Okay, so now this is our original, and we're going to leave the back piece in place. We're going to leave the vertical piece that sticks out in place, but we're going to cut off the front of the what would be a J channel. I'm going to cut that piece off of both sides. So once this piece is removed, we've got a flat piece and then a piece that sticks out 3/4 of an inch. Now we're going to take the new corner post and we're going to cut the back side off. We're going to leave this piece in place along with this piece. So we're going to take that piece and insert it over this flange and then pop rivet it together at the top, and then same at the bottom. That piece is heavy enough and thick enough that it's not going to stretch or shrink very much, not like the individual horizontal strips. So the pop rivets at the top and bottom will not cause it to buckle. But that's how you fix a corner post. So now we're going to install siding over asbestos, existing siding. EPA says do not disturb the asbestos. Just apply a new substrate material over the existing asbestos, and then use fasteners that are long enough to penetrate not only the new substrate, but into the original studs behind the asbestos. And granted, when you nail in, you're going to have some broken pieces fall out, but it will be minimized because the substrate that you add is going to hold most pieces that break in place. Or if you don't want to install new substrate panels, you apply furring strips vertically at 16 inches and then apply the vinyl right to the new furring strips. Over stucco, you want to leave the stucco alone and then take nailing strips and apply them vertically, 16-inch on center, and then foam sheathing applied in sheets. Nail the foam sheets to the furring strips, but use cap nails or nails with washers so that the nail won't go right through the foam. And then apply your vinyl strips in the similar fashion you would on any other installation. Just be sure to follow manufacturer's installation procedures. So in the inspection process, you want to look at the house, look at the big picture. Look at the vinyl siding strips. Do you see any bulging? Because bulging would imply, in a large area, would mean that the nailing strips have been damaged, and the only thing holding the vinyl strips on the house now is the interlock of the bottom of one strip and the top of the next strip. Physically pull on the starter strip just gently to make sure it's secured. Look at the corner posts for physical damage, any J channels and utility trim. Look for damage and make sure they move. Look at how they did the wall penetrations for light fixtures, for electric outlets, for the hose bib, for, let's see. Oh, around, how did they handle the wall penetrations for the electric panel, cable TV, telephone? Look at the fascia and the soffit. Again, remember the soffit material has to be movable, but pay even closer attention to how the soffit vents are handled. Look at the rake ends of the building. Remember, as we were going up towards the peak on the gable end, we got one nail at the top. And that should be, other than the soffit that may have an exposed nail, if you've got 24-inch wide or wider soffits, shouldn't see the nail, but that's a spot where it's not uncommon. But at the peak of the roof, there should only be the one nail holding the top strip in place. And then look for moisture control issues. On this particular house, the starter strip was not present, and the J channel was not correctly nailed to the substrate. So not only was it loose horizontally across the bottom, I could pull the top almost 24 inches of the J channel loose away from the substrate material. Now here, the vertical strip was cut so short that there was nothing to nail to. So since there was no nails to hold it in place, it just blew off. My best guess would be, in this particular instance, would be to take a short strip, put it in place, and then at an angle, put a nail at a 45-degree angle at the center of the strip. I'm sure that the manufacturer may not agree with that, but from logic, that's the only way I can see that strip, as short as it is, would not potentially blow off or literally fall off. Also, take a look over here. First, you see how wide this flange is on this vinyl window. This is a vinyl siding window flange, and it has the 3/4 inch gap behind this face surface so that this piece will fit inside the channel. Now this piece is visible because they cut it 3/4 of an inch too short. So it should be replaced with the appropriate size strip. Here you can see that they had a grounding electrode conductor pass through the wall, and they just separated the joint between two vertical strips and pulled it through. That's a tough one. But since you can see this shadow line here, it tells us that the strips are not interlocked. So this particular strip has got all kinds of problems. Soffit vents, I keep mentioning them because we don't want to install vinyl and knock out the potential for adequate attic ventilation. Now on this one, it's half right. They did put J channel around the perimeter of the electric panel, but the chances are there's no house wrap behind it, behind the electric panel. So my opinion is that the 3 strips of J channel needed to be caulked to the main meter to prevent water from getting in around the perimeter of the box. At least they did put in J channels. I've seen where they just butt the vinyl up against the side of the electric panel. Down here for the, I assume that's telephone. I don't see a box inset into the vinyl, so they have just screwed through the vinyl into the substrate material to support that little box. So as a result, unless they drilled the hole for the screw 3 times the size of the screw, that strip will no longer move back and forth. So that would be something you want to check. Moisture entry at the seams. Now, on this particular house, it is a residing job, and the brick mold and windowsill had already rotted enough that they took metal flashing, folded it, and created covers for the brick mold so that you wouldn't see the deterioration of the brick mold. Well, that's one way of doing it, but this is all dirty, and that implies that they did have some sealant installed, but the sealant is giving way. So as a result, we need to get it caulked back in place to prevent the water from getting in. You can see the drip marks here, which indicate that the water is getting behind. And eventually you're going to rot out that sill even more so. And then what is the metal cap holding on to? We talked about this particular house already, but I pulled it apart so that I could show that they didn't have flashing tape on the window. Since this was loose, I could pull it apart and have a good view behind. It did have foam behind it, but it did not have flashing tape around the window. And this was new construction. And so there's no excuse for there not to have been flashing tape installed, as well as house wrap around the entire structure. Inappropriate deck application. The vinyl siding needs to terminate above the deck and then an inverted J channel under the deck. It had the J channels, but I guess you had to see it to understand it. It wasn't flashed behind the deck. So the J channels did protect the interface between the house and the deck, but this is that same house that did not have house wrap. And so for the deck, it should have had metal flashing tucked up behind the vinyl siding above the deck, and then come out over the top of the band joist, and then another strip of metal flashing behind the piece we just installed, and brought it down behind the joist and had it terminate to daylight below the rim. But the J channels is all they had to protect the substrate material on this particular house. Oil canning, hate to pick on the same house, but this is it again. When they cut the strips around this corner of the window, they didn't leave the required 1/4 inch gap. And so this piece ended up buckling because it was tight here in this window trim and caused it to buckle. So some might say, was the J channel missing? Well, this is that window I described earlier that came to the house with a J channel already built in. And it's real easy to tell on a vinyl siding house whether it should have had J channel or whether this was designed and manufactured with the J channel installed. Because on a vinyl window, they never have this much vertical or this much horizontal plastic or molded trim around the window. This is made specifically with the built-in J channel on all four sides. Now that particular window, this is the inside of that window, and we have water getting in. So if we back up one, this J channel, the vinyl does tuck into the J channel, but if you remember on this particular window where I pulled the vinyl loose, there was no no flashing tape. So the water got behind the vinyl and literally came right on in. And this house isn't much more than a year old. And so that's a lot of moisture getting in. Where the front porch or any concrete slab abuts the house, you have to put the J channel to prevent the water from running down the vinyl and hitting the concrete and immediately going behind the vinyl and potentially into the substrate material and or the rim joist. Just depends on how the concrete slab was poured. I haven't seen it in writing anywhere, but whenever I see this J channel, there's always going to be a little bit of a gap across the bottom of the J channel where it meets the concrete. So I always recommend to my clients to seal that joint to prevent water from horizontally sliding across and getting into the structure. Here we've got a duplex, and this was new construction. They put the vinyl strips on vertically. They did put in J channel around the boxes, but there's gaps, and you can see that there's no house wrap, no flashing tape, nothing to prevent the water, the wind-driven rain, from getting right in. And if you look close, you can see that it's already getting pretty dark right here. The OSB board is, which indicates that we do have water intrusion. This again is classified as an inappropriate penetration. And I guess the best way to have handled that would have been to just cut a notch in the vinyl strip, the two vinyl strips, or at least the one vinyl strip that had the recess area, and then slide it up against the penetrating wire. The only other way you could have done it, which would have been exhaustive, would have been to somehow disconnect the ground wire from the ground driven rod, push it back into the house, drill the hole through the vinyl, and then pull it back out. So this is going to be a potential moisture entry penetration area no matter what you do to it. But thankfully it's right at the bottom of the wall, so I would imagine any moisture that gets in is going to create minimal damage. Here we've got vinyl strips pulling loose. And on this particular house, I did verify the issue was they had nailed the vinyl strips tight. The temperature change did not allow, the tight nailing did not allow the temperature change to shrink the vinyl appropriately. So it tore the nailing fins. This whole area flopped in the breeze and eventually pulled loose. And here you can see that the vinyl is even pulled outside of the J channel. So these pieces need to be pulled out and replaced because the nail holes that went through the vinyl and into the substrate were torn and you can't fix it. So replacement would be the option. Okay, it looks like we're done a whole lot early, but these are two websites that you ought to do a screenshot and take a look at those websites. The Wolverine siding material has a real good description on installing their material, and you can check out the warranty transferability on their particular brand. And then CertainTeed again has a very good site for how to install their siding. But don't forget to write down vsi.org or vinylsiding.org. Either one of those takes you to the same place. But the VSI is the organization where all the manufacturers get together and they agree on how their vinyl siding needs to be installed. So they are the industry leaders, and no matter what brand vinyl siding you have, the VSI installation instructions will cover any of the various brands. I guess I couldn't find the matching color. VSI, check them out. So with vinyl siding, along with any other material, siding material that you're going to inspect, you got to pay attention to the details because that's what'll get you and the installer in trouble. Okay, so now I'm going to cut that out. I'm going to go back to this view, and we only have one question. How are we going to write up vinyl siding with no vapor barrier behind it? That's really a pretty simple thing to write up. If the house was built after 2006, you put in that the siding was incorrectly installed without a vapor barrier and action is required, and then leave it up to the buyer and seller to negotiate how they're going to handle it. As early as 2000, when we went from the in the Midwest, we went from the BOCA building code to the IRC. In 2000, it did not require house wrap behind vinyl siding, but that went away in 2006. So the house wrap should be there in anything 2006 construction or newer, assuming, of course, that your city, state, jurisdiction having authority had adopted the code that requires it. You can also go back to the vsi.org because the oldest version of their installation instructions I have is 2000. And even in 2000, on the very first paragraph, it says this is not a watertight material and requires a water resistant barrier be installed prior to installation. So I hope that answers that particular question. So what do we do about it before 2006? Edmund, it's again pretty simple. You tell them the house wrap or water resistant barrier is not present. They may want to investigate further to determine if there is damage to the substrate material. But again, it's up to the buyer and or seller to decide what they're going to do about it at that particular time. Now, you might want to take your fist and bang on the walls, especially below the lower corners of the windows, to see if the substrate is already so spongy that it moves when you hit it. Hope that answers your question. Brian, let's see, what do you got here? I write up it needs to be replaced before or after 2006. I write it up that it's poor practice and needs the vapor barrier regardless of code. Well, Brian, I agree with you 100%. You're the inspector. You have to determine how you're going to write it up, and even more importantly, what degree of liability are you willing to accept? Now, let's say, for instance, that let's say it's 2000 construction. There was no house wrap or water resistant barrier, and you say the vinyl siding looks fine and everything's hunky dory. Then they decide that, well, you know, this south wall is faded quite a bit. Let's put up new vinyl siding. And they take it off and find that the substrate is just totally saturated and has lost its structural capability. So then the question becomes, Brian, why didn't you tell us about that? You're going to come right back with, well, I couldn't see it. It was hidden. And we can't talk about what we can't see. That's going to be your first line of defense, I would guess. But we all have to accept a certain level of liabilities. So you have to determine for yourself where you're going to draw the line on liability. Richard, how is a power awning supposed to be installed on vinyl siding? What do we look for? Wow, that is a good question. I haven't considered that one. Well, let me think. We still need to have the vinyl siding being able to move horizontally. If you put the screws through and secure it tightly to the vinyl siding, it obviously isn't going to move. Therefore, my logic tells me that I need to cut out the vinyl siding wherever the awning is going to be secured to the structure, put in flashing similar to the deck flashing. That would be one continuous piece tucked up under the top side, bring it down to the lower edge of the siding that remains, and fold it outward so that any water that gets behind the vinyl will hit that leg that sticks out and fall off. Then install a J channel, just like a window, above, to the sides, and below. And then fasten your awning directly to the metal flashing that would now be visible. That's my recommendation. Does anybody else have a varying opinion on either how to install that or answering Brian's question on how do you write it up before 2006? Comments? Don't everybody write at once. Well, we've got a little bit of time. Don't want to cut it too short. Does anybody have question on any other exterior siding materials that we could spend, say, the next 10, 15 minutes on? I'll tell you one of the issues that's coming up in my area. Actually, it's been coming up for a number of years. It's the new cultured stone. I haven't seen anybody install it correctly yet. In our area, we're putting down the one coat stucco, and then that one coat has to be thick enough to cover the expanded wire. And then you take the individual stones, hold it in the palm of your hand, take your trowel, and create a dam around each stone. I'm sorry. First, take your trowel and butter the back of the stone, and then take that stone with the trowel and build a dam around the entire stone, and then push it into place, wiggle it a little bit, and you should have mortar sticking out around all four sides of the stone. Well, that's not what happens in this part of the country. They take the stone, slap across the back of it, and stick it. And as a result, the back of the stone does not get 100% coverage with mortar. And then the rain gets in between the stucco base coat and the back of the stone. And then as soon as it freezes, it pops the stones off. So that's getting to be a real problem in our area, in our part of the country. And to make it worse is siding material is not one of the issues that code inspectors look at or comment on. So it's become quite an issue. And good old Dave Goldstein says, better known as lick and stick. Yes, I didn't want to use that term, but you're absolutely right. That's exactly what we call it up here. It says it's the same problem as hard coat stucco. And with hard coat stucco, I assume you're talking about the stucco not being thick enough or continuous. Dave, you might want to expand on that just a little bit more. And while you're thinking about that, Brian Conley says to everyone, another water intrusion problem is porous EP Henry paver steps installed above vinyl siding at the front entrance area. Because the vinyl siding is not watertight, substrate, I find water issues on rim boards, framing from basement area all the time. I believe I understand what you're saying. They're putting the Henry paver steps, I assume you're talking about on the porch or on the sidewalk that abuts the house. No, because you're saying above the vinyl siding. I'm not sure how to answer that one. Sorry, Brian. If anybody else has a recommendation, please sound off. Okay, David's back. He says, same problem with moisture intrusion due to improper installation. Yeah, well, that's a problem with all the sidings. EIFS got a real bad name because it was tight to the structure at the bottom of the wall, so that the moisture that got behind the foam couldn't get out. Well, then they came out in 1996 with the drainage method, and first house that they did here in Kansas City, they called me. Somehow I got a reputation of being the moisture guru. So they called me and says, hey, Tom, come out and look at this drainage system and tell me if I did it right. So it was a week before I got out there. And when I got there, it looked like he did a really top-notch job. There was only one problem. Along the front of the house, they poured the sidewalk up against the eaves, which encapsulated that plastic channel with the drain holes on the bottom of the wall. So they created it, made it a barrier system along the front side of the house, which totally wasted his effort on making it a drainage system. Let's see. David again says lots of rotted substrate. Well, if the water has nowhere to go to the daylight, it's going to go right into the substrate and framing of the house. That's why the house wrap is so important. Another problem I've run into is brick, a brick facade. A brick facade obviously has to have the felt paper or house wrap behind it. And then it's supposed to have between 1 inch to 4 inch gap between the back of the brick and the house wrap. Well, the purpose of that is water just blows right through mortar joints on brick. And the water is supposed to run down the back side of the brick and come out the weep holes. Well, in our part of the country, weep holes are an unsolved mystery for builders for some reason. But to make matters worse is the house wrap is supposed to go down to the foundation wall, turn and come out to daylight, and the first course of brick, the up to 3/4 inch mortar bed that first course of brick sits in, is supposed to sit on top of the flashing. Well, I've got a picture that I use in my brick presentation that actually shows that felt sticking out between the foundation and the first course of brick. And the only reason I've got that picture in there is to show what it's supposed to look like, even though nobody's ever seen it that way. But the reason it has to come down the wall and out to daylight is the water that runs down the backside of the brick. If there's no weep holes or the weep holes are plugged up, the water has no choice but to go back under the bottom termination of the house wrap and go right into the foundation and rot the sill board. Granted, it's supposed to be treated lumber, so the moisture's not supposed to bother it, but it's got a untreated 2x10 sitting on top of it, which is more than willing to accept the moisture. Okay, let's see. David Goldstein. Home inspectors should recommend invasive testing for AMSV just as you would for hard coat and for EIFS. Agreed. David Goldstein also says, check out website for Mortar Net. Great product for maintaining air gap. Through the wall flashing is never installed, although it's required. I agree wholeheartedly. Now that Mortar Net that David's talking about is the same type material they're using on roofs. In our part of the country, wood shake and shingle roofs now have to be laid on solid decking as a fire preventative. And if you're going to do that, you have to put some type of air gap behind the shakes and shingles so that they can dry out equally from the backside as well as the front side. So they're using that same type mortar net on the roof deck to allow airflow behind the wood shakes and shingles. That's working out real well. Let's see, what other kind of siding material can I give you my 2 cents on? I've got a few more minutes here. Let's see, we talked about vinyl, talked about brick. If you're still using fiberboard material for siding and or OSB board, if you look at the instructions between floor levels, you're supposed to leave a 1/2 inch gap with the Z flashing. Well, that 1/2 inch gap is so that when the house is painted the first time, you can actually get paint on that bottom edge to prevent it from deteriorating. Case in point, here in Leavenworth, I was monitoring construction on a house. It was a tract house, and so all the houses on that street were the same. But before they started framing the house I was working on, the crew was framing the house next door. So I went over and pulled the instructions out of the mud and showed them that that 1/2 inch gap was required along with the Z flashing. Well, on the house they were working on, they had it stacked tight. And so I explained to them that my job was to make sure that everything was installed according to manufacturer's installation instructions on this house next door that you're going to start on next. So I'm showing you this so that you understand that if it doesn't have that 1/2 inch gap, you got a good possibility of not getting paid. And so they started on the house I was monitoring next. And sure enough, they had the 1/2 inch gap all the way around both stories of the house. I was so happy I could jump up and down. Then they went to the next house and went right back to the method they used on the previous house. No gap, no way to paint. And that 1/2 inch allowance also is there for the potential of the rim joist shrinkage. And the rim joist shrinkage is not much of an issue if you're using manufactured lumber because it comes to the yard, from the yard to the house already shrunk to the 9% moisture content. Let's see, check out website. Stephen Brown says hardboard siding. Okay, in our part of the country, we call it fiberboard, but it's the same material. And I sure wish that masonite siding was still available. Masonite siding was the densest material of all the various brands. I was really impressed. They flew myself and one other home inspector from Kansas City down to their test facilities down in nowhere, Mississippi. And they had unpainted siding from every manufacturer out in the yard mounted on frames at 45-degree angles, and the date of exposure. And it was obvious that the denser the material, the less swelling you're going to get. And all of those panels that were on display were unpainted. And after, I believe it was a year and a half, various other brands were literally falling apart, whereas the Masonite was strongest material. Unfortunately, Masonite got bought out by a Germany company who was had control of, or I should say, controlling interest in interior door covering material. So they bought Masonite so that they could get rid of the siding material and convert all of their production to door skins. Masonite was the #1 manufacturer of door skins in the United States. And so by eliminating the siding due to all the lawsuits, they just abandoned the siding and went for the door skins. So I do miss Masonite. Mike Burla says high-end composite siding. Okay, I assume we're talking about Hardy plank and Hardy panel. Nailing is the most critical problem we run into in our part of the country, where the spacing is either too wide or too close together, and moisture gets in at the seams, and in spite of the fact it's not supposed to swell, it does buckle. And then caulking the seams does help, and appropriate spacing, I believe it's 8 inch around the perimeter, is appropriate. I had a building two doors down from my building, office building, and they added a garage on the back side of the building, and the builder installed Hardy panels horizontally, not vertically, but horizontally. And this was about 10 years ago. While he was putting them up, as soon as he finished putting them up, that's when I noticed. And I knew the guy, so I went over and I said, what possessed you to possibly install those panels horizontally? And he says, well, it was a real simple solution. There'd be a real simple explanation. There'd be fewer vertical seams for moisture to get in. He took me back on that one for a minute, but I said, did you by chance look at the installation instructions? They're required to be installed vertically by manufacturer. Therefore, there was no warranty. Now that was 10 years ago. 2 years ago, they put out new installation instructions, and you can now install 4x8 foot panels horizontally. Not sure what changed their mind, but be aware you may run into that on your inspections. Only seen it once, but now it is actually allowed. Well, looks like we're at about 9:56. Do we want to go ahead and just take a break now? And we'll be back at, would be, let's see, it'd be 7:10 my time, 8:10 your time. and we'll do electric.
That is correct. So let's take a 10-minute break. Don't log off, stay on, and we'll see everybody in 10 minutes.
Okay, and be sure to stick around for the second half because the last 10 or 15 slides are going to be on house fires and a arc flash that put a guy in the hospital for 5 months. See you in 15. Thank you.
Thank you, Tom. Take us a nice break. A couple of messages. Whoever
Yeah.
is caller number seven, please identify who you are. If you hear this, put your mic on or send me a message so I don't have to send a cert to caller number 7 because it won't get anywhere.
Well, caller number 7, if you're still here and listening, I'm Tom Lahan with the Midwest Inspectors Institute in Leavenworth, Kansas. My email address, I'll tell you now, but I'll put it.
No, Tom, I
John
need,
Elastic.
Ask if your caller said.
okay.
Am I caller 7?
If that was caller number 7 just responding, please repeat that.
I'm John Elastic. I'm not sure if I'm number 7 now.
You
Okay.
are. You are. What's
Oh,
your
hey, Neil.
Go
what's
ahead,
the
John.
609
right?
977
Hold it. 609,
977
right?
3531.
Thank you, John.
Thanks, Neil.
Thanks for being here.
During
And the
break,
next-
I'll put my email address on the end of the electrical inspection presentation.
You got it. Thank you. And the next message goes out to Chris from A Closer Look home inspection. Chris, please send me your last name. Send that through a text message. I have asked you. So please give me your last name so we can properly identify you and give you the cert for tonight's seminar.
Before you go on, John, are you on both by camera and by phone? Because you come up twice.
Dave, I'm not sure.
We're in with a tablet. He's in with a tablet through GoToMeeting, I think.
Yeah,
It is twice, yeah.
John, did you call in by phone also?
No.
No.
All right, then Neil, that's somebody else.
Okay, because John, you are here then. Okay, that's why I
Yeah.
took down his phone number, because it comes in as a log sheet with the phone number. Again, I have a caller number 7 who's on their cell phone. Please identify who you are.
It's not me, Charlie Wright, right?
What?
It's not me, Charlie Wright. I'm in there, right?
You are in.
Okay.
I'll have to send you a text message later, and hopefully you respond then. And again, thank you, Chris, for identifying.
Tom, you might want to take it up to your first slide so nobody sees those last ones.
Yeah. I just needed to put my name and phone number on the last slide. Well, looks like we still have 72 people on board. That's a good sign. I haven't scared anybody away yet.
Actually, even funnier, we gained 3 people.
We gained two. Well, word got out that I was the speaker. You know,
That's exactly what it was.
yeah, I'm sure.
Question is, who's the 3 people that joined?
Why I'm here.
Oh,
Well, and
Neil
then
Bob
too,
Allen just came on.
I came on again, I lost, and I'm back on.
okay.
We were talking about you earlier. That must be why you came on.
I had to be good.
Okay, we'll go with that.
well, you know, there are 72 people, but we have no idea how many of those are awake.
Thanks, Bryce. You really can't do that.
Don't go there.
I'm going to leave the room for a moment. I'll be right back.
Just don't take your camera with you.
Okay, he's got pants on.
You know, the old story where, I don't recall what program it was, but, on one of the, I think it was one of the late night programs, he had the mic on his, jacket and he went into the bathroom and he forgot the mic was still on. Or it's a news program, one of the two, something like that.
Where's your phone? Where's your phone?
When we're offline, I'll tell you the story of when my daughter was in school and one of the teachers did something similar.
Oh, God.
I'll tell you that one later.
Well, actually, on a funny one, and everyone listen, there's in Florida, there's a, shows you how bad of a person I am, probably. There's a ice cream place, and there's a bathroom in the back of the ice cream place. And when you close the door and you lock it, the windows fog. But when you unlock it, the windows are, you could see into the bathroom. Well, Jenna goes into the bathroom, and as the mean type of person I am, and she locks the door, I go, Jenna, everybody. You know where I'm headed on that, Dave.
Just remember, this is still being recorded.
Right. I didn't say it. Oh, God, now I'm in worse trouble. Recorded, and I have 72 people who heard it.
Leave it? Stop it? All right, let's see. You listen. What meeting is it up? Oh, that's easy. Tomorrow? You guys gonna have it? You're gonna be ready for it.
They're preparing for fireworks.
The lunch.
Hey, David, are you there?
Yeah, Tom, I'm right here.
In your part of the country, do you call the downstream panel a sub panel or a downstream panel?
Sub panel.
Okay.
So put my pictures in. Tom, did you put my house in there?
Did I what?
Did you put my house in there?
Oh, yeah. Yep.
I'll have to send you a couple of pictures that I have of the vinyl melting because of the low E glass and the
Right.
reflectivity.
Yep, it happens.
I got a whole development where it was happening.
Oh, wow. Hey, how's my volume? How's my volume? Am I too loud, too low? Or right in there?
You're fine.
Did you send him that picture you and I took, Dave?
No, I didn't. I know the one you're talking about. I got to find that one. But I've got another. Do you
That's
still
the
have that?
worst I ever saw.
Development not far from me, over 55 community. That puts that one to shame.
Oh, really?
Yeah. I got to find that one that you and I took. Tom, just as a reminder, for what it's worth, everything here is NEC.
Everything what?
Remember, I told you everything here is NEC.
Yes. I added some NEC references.
Tell me when you're ready. It looks like a lot of screens are blank, which means people have left their computer.
Yes, I see that.
Not true, Neil. I've been here the whole time staring at the blank screen.
It's not blank now. What do you see on it, Jerry?
All I see is electric panels, sub panels, electrical NEC, FCI, and your ugly face.
Oh. Jerry, there's 72 people on, so watch what you say.
Being good.
That sounds like fighting words right there.
I know, doesn't it?
It does.
I got a lot of
It's
people
probably,
that
it's
are behind me.
probably okay when Jerry talks because everybody knows him.
Right.
True. Especially at National. And they love me.
I don't know if I would go that far, but they definitely know who you are.
I was going to say that's one man's opinion.
Right. I'd say everybody who thinks National loves them, raise your right hand. If you don't raise your hand. Oh, okay. I see one hand, but a lot of the people have their screens closed, so it's okay.
Somebody had to raise their hand.
I know somebody.
Jerry, I hear your name come up all the time at National.
I'm sure you do.
Yep. I sure miss not going to Ashley this year.
Yeah.
I bet the vendors are hurting.
Definitely not the same.
Why, you didn't have fun in Vegas?
I'm talking last month or in January this year.
That's what I mean. You didn't have fun in Vegas this year?
Nope. Should have gone though because we had lousy weather.
Yeah. Now
Is Rick online?
Rick, I think, is on by phone, Jerry.
Rick, can you hear me?
I can hear you.
I just sent in some information to Triple Play. They want to know if we're interested in doing December. I said it depends upon the condition of the state. Oh, I'm serious.
When's the application due? When's the application due?
Well, they don't know yet because they don't know if it's gonna be, virtual or if it's gonna be reality. They had asked if it's approved by the state and they can do it, would we have a problem renting rooms? I said, maybe, maybe we'd have a problem.
Oh, God.
If it's going to be held virtual, I don't think we want to do it.
Oh, pretty much waste of money.
Agree.
Where would the room be? At Trump Plaza?
No, but you
You
gotta
can
bring
get them pretty cheap right now.
Yeah, I think so.
Anyhow, usually we're not required until April to send anything in. So if in fact they're ready to do that, I don't know.
Did we give a deposit for 2020 or by the time the deposit was needed, it was what?
It was April. And we knew in April that they weren't going to go.
Oh,
in
okay.
December.
Gotcha.
is Carlo on tonight?
Yes,
He's here?
yes.
I'm here. I'm here.
Okay. I just wanted to make sure you heard the conversation.
Absolutely. How you doing, Jerry? I'll be there.
I'll bet you will. You'll be there by hook or by crook, right?
There you go. We with you by my side.
Oh, God.
What's that?
All I said is, oh, God.
Well, it's already 17 after, so we really need to get started.
Yeah, so let's start.
Okay. Let me shrink all this stuff. All right.
Go into
Electric,
part two.
go ahead.
No, what I said, going into part two.
All right, electric panels, sub panels, electrical issues, and we'll talk about some NEC and some AFCI stuff. You know, this cover picture was really interesting. The house was about 50 years old, and they installed this
My mom
new.
call you? Can you use your phone real quick? Call my dad real quick. Okay, just have to make it.
Carlo, you need,
Mute your system. Carlo, mute it.
Okay, it's a 50-year-old house, and they added this panel under the spyglass, and it was used strictly for branch circuits. So I went into this house, and I see all this, and there's only two 240 volt appliances in the house. Three, I'm sorry. Range, air conditioner, and clothes dryer. And they've got 1, 2, 3, 4, 5 downstream panels. So what do you say when you walk into a house that has all this? Now, this is a 100 amp main. This was the branch circuit wiring. Then they added this one to cover the new branch circuit wiring because they put in all 3-prong, so all the circuits were grounded. But they had all these other panels, and I never could figure out what the hell they went to because they didn't have enough appliances in the house to warrant them all. And so finally I just said, okay, you need to have an electrician come in and figure out what the heck is going on and what can be eliminated because there was only one out of. They still had fuses in them, so I have no idea what they were doing. At any rate, let's get going. I'm sure you guys have all run into a house like that also. Definitions. A hot is the current carrying conductor, and they haven't messed with that name. The neutrals, on the other hand, are now called the intentionally grounded conductor. It is the conductor. The power goes from the hot through the load, and this conductor goes back from the load to the panel. And then the ground is no longer a ground. It's now the equipment grounding conductor. And, you know, in this politically correct society, you never use one word if 3 words will work. So that's where it came from, I'm sure. So the ground is now the emergency means for electricity to discharge where there is a fault or failure of the neutral wire. Some call it the alternate path back to the panel, and then from the power panel to the pole or the ground driven rod. I'll use those terms interspersingly because I forget. A feeder is for a downstream panel, like one in a separate structure. And they require a 4-wire feeder unless there's only one circuit. Then the 3-wire feeder is acceptable, but it will have its own ground-driven rod. Now, where the detached structure is installed by prior code and there's no other metallic connection with the main structure, the neutral and the ground are bonded together and the fault discharges to that ground-driven rod. Okay, now The NEC has made the same statement as the IRC since 2008. The 4-wire service is required. Now, the only time you're ever going to find in current construction, not even current construction, say in the past 20 years, a 3-wire feeder to the separate structure is if there's only one circuit, and that's a 15 amp, just for lights and an outlet. Other than that, it needs to be a 4-wire feeder. If you have a downstream structure and it has more than one circuit, it has to have a minimum ampacity and panel for 60 amp. And then again, where the detached structure has only one breaker, it does not need to have its own grounding electrode. But if it has more than one circuit, it has to have the grounding electrode, and the wire going to the grounding electrode is the grounding electrode conductor. It does have to have its own disconnect. So rather than a downstream panel without a breaker, to kill the power for that panel, it's going to be a 60 amp panel, and it has to have its own disconnect for the entire panel in that outbuilding. Are you guys familiar with Mike Holt? Mike Holt lives in Florida, and this guy is literally the guru on electric, especially electric bonding. There's a difference between grounding and bonding, and that's a separate lecture altogether. But I just want to give you a heads up on how brilliant, I guess, would be the word for Mike Holt. Every year, except this year, I go to Denver every week, first week of March, to sit through 40 hours of code classes. And if he's teaching a class, I don't miss it. And this one class that I went to, he was doing strictly on bonding. And at the end of the session, he was so comfortable that everything in that room was appropriately bonded. He took an aluminum pitcher of ice water, took the, what do they call the extension cord with 5 or 6 outlets on it? I guess you can't answer me, but whatever it's called. He took that and dunked it in the pitcher of ice water. It had his computer and the ceiling projector plugged into it, and it maintained current flow. Then he grabbed the pitcher. This is an aluminum pitcher with ice water in it, and that electric strip with the computer and the overhead projector plugged into it, lifted it up, and took a sip of water out of it, and did not get electrocuted. The second time I went to that same lecture, I took a picture of him with the electric strip in the water and him holding it. I took a picture at that point, but the flash went off. So when he put it up to his mouth, I was chicken and didn't take a picture of him with the pitcher of water in his mouth. But if a structure is appropriately grounded and bonded, the system should discharge itself without affecting you. Think about that for a second. A pitcher of water, aluminum pitcher, and he could touch it without getting shocked, and then took a drink of water out of it without getting shocked. So grounding and bonding, being two separate things, still is very critical to an electrical system that is wired correctly. All right, let's talk about the main electric panel, bus bar layout. So the A leg is on the left, B leg is on the right. The neutral or intentionally grounded conductor bus bar is in position number 3. And on this one, it's on the left side of the panel. Number 4 is the ground, which is now called the grounding bus bar, is on the opposite side, the right. And then the main overcurrent device and or main service disconnect is number 5. Now the main overcurrent disconnect and the overcurrent device in a breaker are one and the same. In the older panels, fuse panels, for instance, the main overcurrent device was the twin fuses. The main service disconnect was either a knife switch or a rocker switch. But in the current construction on residential, number 5 is both the disconnect and the overcurrent device. Bonding screw. On a main panel, there has to be a bonding screw or a bonding strap. Its job is to bond all the components together so that the panel box itself cannot bite you. So look for that green bonding screw. And in some panels, instead of literally the green bonding screw, they have a metal strap going from the grounding bus bar to the panel. And over on this picture, you can see the bonding strap, and it even has the green ground screw. So we want to make sure that everything is bonded appropriately. Now in a downstream panel, we do not use a bonding strap or a bonding screw. And we'll get to why that is a little later. Now the grounding electrode is going to be an 8-foot rod mostly, and it has to have 8 foot of soil contact. Now here we can see the 8-foot rod with about 12 to 18 inches sticking above ground. So the question becomes, did the electricians not hammer that all the way into the ground? Well, in this picture, it's real easy to tell because you can see where the damp proofing was applied on the foundation wall. And so the soil level was up here. So however many years ago this house was built, that probably was at grade or at ground level. And you can tell secondarily that it has settled that much. Look at the downspout. It's a full 18 to 20 inches above ground. So what do we do about this rod? Well, the most effective answer is to take a hammer and drive it back down into the ground so it has 8 foot of soil contact. If we have 8 foot of soil contact, how much of that ground rod should you be able to see? This is called a pregnant pause while I wait for a response. It's never going to happen. So the answer is you shouldn't be able to see the rod. Might be able to see the top of the rod, the horizontal surface, but you should not be able to see any of the rod. Otherwise, it does not have 8 foot of soil contact. Now let's look at it from the point of view, maybe it's driven down as far as it'll go and doesn't have 8 foot of soil contact. What do? You can't cut the rod into 3 or 4 pieces and go down 20 inches on each of them. So if you can't drive it down and get 8 foot of soil contact, the second option is to pull the rod out and hammer it down at a 45-degree angle. Now, if you hit bedrock and still can't get it all the way down below ground, then your only other option, if you're going to use a ground-driven rod, is to take dig a trench 8 foot long, 30 inches deep, and lay the 8 foot rod in the bottom of the trench. You can't cover it until your code official comes out and sees that it is there and the grounding electrode conductor is connected, and then you can bury it. So there are solutions if the rod is sticking up. Hopefully you can just drive it down the rest of the way, assuming of course that there's enough grounding electrode conductor available to drive it down that far. Another option would be to bring in the dirt that is now gone. Where did the dirt go? It's real simple. When you backfill around the foundation, you are required to compact the soil. Some builders just use a garden hose and saturate it, and then keep adding soil on top until it quits settling. But generally, they try to get the house built and move on to the next one. So as a result, we end up with this issue if they haven't compacted the backfill in layers on the way up. There are options. If you don't want to use the 5/8 diameter ground rod that could be stainless steel, copper coated, or zinc coated, you can use a ground pipe, which is a conduit 3/4 inch diameter, galvanized or zinc coated. You can use the water line, but if you use a water line, it has to have 10 foot of soil contact beyond the foundation of the house. And chances are, if you do have, say, copper or even old galvanized coming through the wall, in our part of the country, the meter is buried out in the front yard. So as long as the meter is 10 foot away from the house, you're pretty much assured that that is a contiguous pipe. The newest thing in our part of the country is to use a UFER. A UFER becomes a part of the footer of the entire house. In the footer, there are two parallel number 4 or 5 rebar around the perimeter of the house in the footer. And each of the 20-foot rods are wire tied together. So the footer rebar completely encircles the house. And because it is below the frost line, which means in most part of the country, it's going to be at least 30 inches down, it's below the frost line. So the footer itself is continuously moist. Now, footer is concrete, and concrete transpires moisture. That being said, the rebar in the footer is wet continuously. So the footer rebar, you bring it over to wherever you're going to put the meter and the electric panel in the house. You take another piece of rebar before you pour the concrete, and you wire tie it to any piece of the footer rebar. You bend it so that it comes up through the footer, through what will be the wall, and terminate at least 6 inches above the concrete wall. Then you pour the concrete wall, you build the floor platform, and you build the house. But in the meantime, the UFER is sticking up into the foundation area somewhere around the perimeter of the house. Then we can take our grounding electrode conductor, which is the wire, bare copper wire, and go from the panel right to the UFER. And then the misguided current, we'll call it, will go through the UFER to the footer, which has the rebar in it. And because the soil is damp, the electric current will radiate outward, looking for the telephone pole that has the bare copper stapled to the underside of the pole. I'll get into that a little bit in a few minutes. Another option is a ground ring. A ground ring is nothing more than 20 foot of number 2 copper buried 30 inches below grade. You can string it out or you can coil it like they do on the bottom of the power pole out in the backyard. Either way is acceptable. It just has to be a number 2, can't be spliced, has to be contiguous from the panel or the meter, depending on where the grounding electrode originates. And then another option is the plate electrode. With that, you just take a 1/4 inch thick, 2 foot by 2 foot plate, bury it below the frost line, and it becomes the ground rod. Those are all options, and just depending on your soil conditions, if you've got bedrock 10 inches down, obviously you're not going to use anything other than the UFER. At any rate, there's various options on how to get the ground connected. So here we've got the UFER connection, and the only thing that is critical about the UFER connection to the grounding electrode conductor is that that joint has to be permanently visible. So you just take a frame the sheetrock around it, and put a cover over it so that the code official or anybody that needs to do service has accessibility. This was, I did the codes for a preschool in Powhatan, Kansas. It's an Indian tribe. And they're an independent nation, so they don't have codes. But they ended up getting the short stick on anything they built. So I went to them and offered my services as a code inspector. And when I explained to them that my job would not only be doing code inspections on the structure, but it would be monitoring the construction to see that literally they get what they paid for. So at any rate, as I'm going through the construction process, the electrician, he's pretty far along, and I couldn't tell what he was going to do for grounding. So I wrote it up 4 times that I need to know how you're going to effectively ground the system. And he kept saying, don't worry about it, I'll take care of it. So I went out for my final electrical, and this is what I saw. He's got the rebar sticking up through the floor, but the guy wasn't smart enough to blow the drill dust away. So I walked over, saw the dust, grabbed the rod, and just pulled it out of the foundation. All he did was drilled a 4-inch deep hole in the concrete slab and stick a piece of rebar in it, inferring that it was a UFER. Needless to say, I was not a happy camper. And since I had had several discussions with him previously on other issues, I decided that I was going to be, shall we say, not lax on this topic. So I said, call me next week if you get it figured out. He called me a week later, and he was really being a horse's patootie. So what he had done was just drilled a hole through the rim of the house and put a ground-driven rod in. Well, since he was being such a ornery character, I decided, well, 2 can play at this game. So I took out my volt ohm meter and put 1 wire on top of the rod, went over, I don't know, somewhere between 5 and 6 feet, however far the 2 wires would stretch apart, stuck the other probe into the soil, and I had over 25 ohms resistance. So I wouldn't accept it. So I says, call me next week when you get it figured out. So he called me next week, says, okay, I'm ready. So I went out, and he actually did have a second 8-foot ground-driven rod driven into the ground, 6 foot away with a jumper from the first first rod to the second rod. I got out my volt ohm meter, and he had 22 ohms resistance, so I had to accept it. But if you happen to be doing new construction, be ever mindful about a pile of dust around a drilled hole when they're trying to tell you they've got a UFER installed. One wire, one screw. The white wire is called the intentionally grounded conductor. It is a current carrying conductor. If it was not a current carrying conductor, it would not be insulated. And no matter what code or what age code you look at, the current carrying conductors are required to have 1 wire, 1 screw. Therefore, on the intentionally grounded bus bar, there should not be 2 white wires under 1 screw. I'm not sure how long that's been in existence, but I know it's, say, 15 years ago or older. On the bare copper side, they are bare, therefore they are not current carrying conductors, and you are allowed to stick as many wires under a screw as you can squeeze into the hole. But the current carrying conductors, one wire, one screw. Oops. Well, my mouse is really active. Here I'm pointing at 2 wires under 1 screw. It's a beige handle, so we know it's the Cutler hammer breaker. And a Cutler hammer breaker only allows 1 wire, 1 screw. That not only is a code issue, but the manufacturer of the panel and the breakers say 1 wire, 1 screw. I'm going backwards. Now there is a brand called Square D. I don't know how popular that is up in your area, but it's big down here, that has a double saddle. So it has 1 screw, but it has connection for 2 wires to the 1 breaker. Now Square D also makes a private label breaker that's called Homeline, and that breaker is identical. The only visible difference between Homeline and Square D is Square D has a label that says Square D, and the other one has a label that says Homeline. But in addition to that, on the Square D brand, on the side of the molded case, it shows the double drawing of the double saddle and tells you what size wires, plural, you can put under the double saddle. Now, when you go back to virtually every other brand, they've got 1 screw and 1 saddle. The instructions say 1 wire, 1 breaker. You can put 2 wires under 1 breaker because the saddle is big enough to allow 2 wires to get into it. However, when you torque it down, if you're really brave sometime and you find a double tap like that, grab 1 wire and give it a little tug, grab the other and give it a little tug, and chances are one of them will pull right out. And that's because when you try to torque 2 wires under 1 screw, you don't get the torque that is actually required by the manufacturer because of the gap between the 2 wires. When you put the screw down, it deforms one of them a little bit. And so one of them ends up being in there tight and the other one is almost finger loose. That can result in arcing, and everybody knows the story on arcing. This guy was real ingenious. He explained to me that that was parallel wiring. Parallel wiring is something used on commercial construction. And the first rule is that you can only use parallel wiring on cables that are larger, that are 1/aught or larger. So a 1/aught wire is just a little bit smaller than your little finger diameter. And the lug that you're going to connect it to is sized appropriately. This guy was trying to convince me this was parallel wiring when all it really was a triple tap, 3 wires under 1 screw. So just be aware that if you hear the phrase parallel wiring, it's going to be good size wire. I did a job down in Austin, Texas. It was, this was an interesting one. It was a 200,000 square foot call center for insurance company. And they built it across the street from the Austin city limits. So Austin city code inspectors wouldn't go over and do the inspections. So they paid me to fly down there twice a week for 3 months to monitor construction and do the codes. So while I was there on my second trip, I went across, I don't know, about 6 blocks into the Austin side of the city limit and talked to the fire department and explained to them that they really need to come over and do the life safety inspection on the electrical, because they were the ones that were going to have to come out over and put out the fire. So they agreed. So they did the fire code issues, and then I did the codes on the rest of the building. But the reason I brought it up in the first place is we had a 1600 amp breakers, 3-phase, and out in the parking lot, we had a train engine with the generator for backup power. The cables that provided the power from the backup to the interior of the building were triple 4-aught. Actually, they're triple 350 kcmi LSs. That wire is the diameter of your thumb. And to get it into the building, we had to pull 3 cables through conduit from the outside to the inside. So the only way it could be done was we had a backhoe on the inside of the building, an 1.25 inch diameter rope going all the way through the conduit, tying on to the 3 wires for each leg, and then dragging them through the conduit to connect them to the appropriate breaker on the inside of the building. Well, think about that. Three wires the diameter of your thumb. That is parallel wiring. So we had 3-phase. So we had 3 for the hot leg, 3 for the, let's see, A leg, 3 for the B leg, 3 for the neutral, and then the ground. Just the cabling alone had to cost a fortune because it was all copper. But at any rate, parallel wiring, you're never going to find it in residential construction. It's nothing more than double or triple tap. Here we have double tap again on the Cutler hammer breaker, and it's not allowed. Fused neutrals is not allowed. Now I have to explain that old houses in Kansas City area, about the oldest thing you're going to run into is about 150 years old. Whereas I understand out your neck of the woods, you can more than double that for an old house. But electric has only been around since 1903, and probably not even that recent along the East Coast. But when Thomas Alva Edison first came out with the electric panels, he had both hot and the neutral fused. Well, it's not a good idea to fuse the neutral because you don't want to take a chance on a fuse blowing and eliminating the potential of the current flow getting back to the panel. So this is the only picture I've ever taken of fused neutrals, whereas I imagine you guys have seen many more than that over your years. But fused neutrals are not allowed. Now the meter, I guess I can talk about the meter can itself. For anybody that happens to be new into the business, you can size the amperage to the house. One way is to take the meter can into consideration. A round meter can is 60 amp. A square is 100 amp. And then once you get over 100 amp, it just grows. Now, the only reason the cabinet grows is because the diameter of the wire, the service entry conductors from the drip loop down, when they enter the panel, they have to make 2 turns. Most of the time you can get by with 2 45-degree angle turns to get it under the A leg lug and the B leg lug. The panel grows in size because the turning radius of the diameter of the wire, as the ampacity increases, the diameter of the wire increases, and it's pretty difficult to bend say a number 2-aught copper wire at 45-degree angles in the space that's allotted inside the cabinet. So in reality, you're never going to be able to get a number 2/0, which is 200 amp copper, into a 60 amp panel, a 60 amp meter can, and be able to make the appropriate turns, because there's just not enough room for it to happen. So 60 is round, square is 100, and then from 125 up to 400 amp in residential, it just gets taller and wider. Now, this particular house was a remodel, and originally the electric panel was on the other side of the wall. Well, when they remodeled the house, they took the garage, raised the floor, and made it a kitchen, a bathroom, a laundry, and a big walk-in pantry. And they didn't want the electric panel in the garage, so they moved the electric panel to the basement, which is on the opposite side of the garage, and then down to the underground level. In doing that, the main disconnect cannot be that far from the meter. So they put the meter and the main disconnect and main overcurrent device on the exterior of the house right next to it. So you lift this up and it's got the 200 amp main breaker. Downstream panels are treated differently than the main panel. On this particular house, the main panel is here, has the main overcurrent protection device and the main disconnect. And we've got a hot, and a neutral. And I imagine somewhere in all this mess, you'll find the bare copper ground going to the ground driven rod. The downstream panel is controlled by this breaker in the main panel. And if you follow the wires, you can see they come over and go to the A leg, the B leg, and the neutral. There is no main disconnect most of the time. It can have a disconnect, but it's not a main. It just kills the power in this particular panel. The panel should not have a bonding screw, and the intentionally grounded conductor bus bar on this side and the grounding electrode conductor on this side should not be tied together. So in addition to it not having the green screw, which connects the bar that's tying those two bus bars together, that green ground screw connects it to the panel. So the screw needs to be gone and that bar should be gone. So that if there's a problem, all the power will go back to the main through the neutral or through the grounding electrode conductor that you can't see because it's not there, over to the appropriate bar on this side. How that works, I'll explain in a little bit. Now the question is, on this particular panel, are those both 200 amp main panels, or is one of these a downstream panel? And the only way you can determine that is to look at what you think would be the downstream panel and see if it's fed by breakers from the main panel. There's no physical connection through wire or metallic conduit between this panel and this panel. Therefore, they are two independent 200 amp panels. Now, the problem you run into when you're doing your inspection is when you get to the meter can, where those two sets of cables would go into the bottom of the top or the back side of the meter can, it is impossible for us to determine whether that meter and the cable, usually a lateral going underground to the meter can, is rated for two 200 amp panels. The way you would make that determination would be to break the seal on the meter can and pull the cover off. Well, we're not allowed to break the seal on the meter can. So in your report, what I say is there appears to be two 200 amp panels fed by one meter unable to verify whether the panel and the lateral are rated for 2 independent 200 amp panels. And then I should make the recommendation that they have a certified electrician come in and make the determination. Inside the meter can, there should be a double lug installed, or the second lug added to the main lug for the A leg and the B leg and the neutral for appropriate connection. But since we can't take the cover off, we have no idea what it looks like inside the can. Here we have a downstream panel that looks like it's done correctly. Surprise, surprise. A leg, B leg, neutral. The intentionally grounded conductors are separated from the grounding conductors. I don't see a bare copper coming from here back over to the main panel, assuming that this panel is inside the house next to the main panel. If it's a downstream panel, it has multiple breakers, therefore it should have a ground-driven rod, but it also has to have a disconnect out in the garage, the separate building. It doesn't have, therefore in this particular case, I'm going to assume it's going back to the main, which is right next to it, but there is no fourth wire. And that fourth wire is important, and we'll get to it in a little bit. Check for top loading. I know you guys have seen hundreds of them, just like I have, but this one took the cake. It's got 3 red wire, well here, it's got 3 black wires in front, and then there's 1 on the back side. Same here, we got 2 on the front, and then there's 2 on the back side. Well, this is the 60 amp wire coming in, going into the lug for the A leg and the B leg. The question is, first off, how did they manage to get those other wires in there without getting electrocuted? But the second thing is, the lug that 60 amp wire is going into is sized for a 60 amp cable. So how did they manage to squeeze in 4 more, they got to be 20 amp wire, just looking at them, 20 or 30 amp wires. How did they get all that squeezed under a lug that was sized for one 60 amp cable? At any rate, top loading. The reason we can't allow top loading is on the line side of the main disconnect and overcurrent device, we can pull this 60 amp lug out and it'll kill all the power in the house, but it will have no effect on these 4 added circuits. So there's no way to kill all the power in the house at the main panel, which is a requirement, with one slight exception. And the exception would be all the power in the house has to be disconnected with 6 hand throws. So let's say, for instance, that not only do we have this main, these 4 panels are 1, 2, 3, 4 right next to the main. If that's the case, I can still kill all the power in the house, 1, 2, 3, 4, all 5, with 6 hand throws. And a hand throw is not where you put the side of your hand with your little finger extended upward and grab 4 or 5 breakers at once and flip them. A hand throw is 1 finger, 1 breaker, 1 throw. So if I have 4 panels next to this main, I have, without moving, in order for this to work, you have to be able to have your feet planted firmly on the ground, reach over and kill all those panels without moving. So as long as there's 4 panels on the side, in addition to the main, I still have less than 6 hand throws. I didn't have to move, and I killed all power in the house. But we still have the initial problem of how do we get 4 additional wires under a lug that's designed to carry one 60 amp wire. So no matter how you cut it, you got to right up top loading. The photo below, it has the 100 amp wire coming in to the A leg and the B leg, and just one wire behind each. The box was full. So instead of creating a downstream panel controlled by this breaker, twin breaker, going to the downstream panel next to this panel, he just top loaded because it was easy and it was cheap. It's not correct and it's not safe. Therefore, make sure you're writing those up. So the lug connecting the service entry conductors is sized for that wire only. The downstream panel would not be protected by the main breaker, fuse, or disconnect. Here we've got the 2 hot legs with a separate circuit, and we even have it connected to the intentionally grounded conductor. Again, not acceptable. What is a floating neutral? The neutral bus bar in a downstream or sub panel cannot be bonded to the grounding system. So in other words, this bus bar and this bar cannot be tied together with a bar running across between the two. Additionally, we can't have a bonding screw tying these two to the panel board. The neutral must be floating. There should not be conductivity between the neutral and the ground at that location. Why? The neutral is a current carrying conductor. Therefore, the neutral is insulated. It is not a substitute for the ground. The neutral is intentionally grounded at the main, and that is so that if there is a ground fault, a short, the signal will get back to the main panel quickly. Whoops, don't want to go there yet. Let me add some more explanation here. There's a thing called parallel path. Let's go back to this picture right here. If these two are tied together and one of these breakers has a short, some of the current will flow back to the main panel through the insulated neutral, and some of the power will flow back through the bare copper wire. The problem is when that signal from this cable gets back to the main panel, the overcurrent protection device in the main panel, not enough of the current flow goes through this wire and this wire at the same time to tell the breaker that there's a problem in this panel. So instead of the short tripping the breaker in the main panel virtually immediately, it takes its sweet time to figure out there's a problem because not all the current is flowing back through this one or flowing back through this one. So as a result, that ground fault will remain hot until the main panel figures out there's a problem. So you are not allowed to have parallel path back to the main panel. All the signal needs to go back through one or the other. All right, now we're going to talk about my least favorite breaker panels. I've got a half a dozen of them. And there is controversy over home inspectors commenting about the, the condition of the panels that they can't verify. So for instance, Federal Pacific breakers are known to have problems where the breaker does not trip under a load. Well, without the home inspectors testing the breaker to determine at the time of the inspection that it will actually trip and then reset, technically, we should not make a comment about the possibility of the breaker not tripping or not resetting. Well, I assume you guys are on the same page where we write it up because we understand either through personal experience or consensus of the group that they are just flat out dangerous. They haven't manufactured it since the early 80s, and they've known there was a problem with them since the early 50s. And your buddy up in New York, whose name has totally escaped me, if you go to this website, he's got all kinds of data on specifically Federal Pacific panels. Well, the first few years I did inspections, I was dubious as to how serious of a condition that actually would be, or potentially could be, I should say, until I had firsthand experience. I was remodeling one of my rental houses, and it had a 100 amp Federal Pacific panel in it, and you'll see the picture of it in a minute. And when they added on to the house, that 100 amp Federal Pacific panel became a downstream panel. And they had a 200 amp main panel in the addition. Well, the main bathroom, it was a 3-bedroom, 1-bath house built in 1960. And that house did not have an exhaust fan, or that bathroom did not have an exhaust fan. And since I was doing all this heavy duty remodeling, I decided, well, heck, I ought to go ahead and put in an exhaust fan. And I know where the wires are coming through to the bathroom because I was in the attic and I could see this junction box that was just totally packed full to the point where they put a second junction box without a back on it on top of the first one so that they could enclose all the wiring that was in there. Well, I knew pretty much which wire I wanted to tap onto. So I grabbed that wire with my long nose pliers. And as I pulled it out, I guess I squeezed a little too hard and went through the insulation on that hot wire and touched the junction box. And there was a little bit of a flash, and then it got real dark. And so I came down out of the attic, and that part of the house was dark, but I knew where the downstream panel was, where that wire would have come from. And I went down to the electric panel in the basement with no windows, so it's really dark down there. And I felt each one of the breakers, and none of them were in the trip position. So I took each breaker and went from on to off and then back on, and did that for all the breakers. Went back upstairs and we still had no power. So I thought, I suppose it's possible that that lucky wire that I grabbed was coming all the way from the new panel in the addition. So I went back over to the addition side of the house, and it was dark. It was the middle of the night, and I found the panel, opened the door, ran my hand down both sides of the individual breakers, and none of them were tripped. I thought, what in the hell is going on here? Something had to trip. I reached up and it tripped the 200 amp main. This lowly little 20 amp wire that I shorted didn't phase the 20 amp breaker in the Federal Pacific panel, and didn't phase the 100 amp breaker in the Federal Pacific panel, and went all the way back to the main panel and blew the 200 amp fuse. After that, I was a believer. They do not necessarily trip when they need to. So in the Kansas City market, we write up Federal Pacific panels as being considered dangerous, have a qualified electrician come in and verify, not inspect, but verify the condition of the individual breakers and the panel. We don't say to have him inspect the panel because that's what we got paid to do. We're giving him a reason to come out because it's a known problem and we can't verify doing a home inspection, whether or not those breakers are in good enough condition to trip and then reset if needed. Whereas an electrician can come in and he can put a load on each breaker, causing it to trip, and then resetting it to determine that it is actually functional. But that's the story on Federal Pacific. So this is the 100 amp panel that I had in my rental house. And incidentally, it had 1, 2, 3, 4, 5, 6, 7 breakers, plus the range breaker. And when I put in the new 200 amp panel, I had to put in either 12 or 14 breakers to handle everything that this panel was handling. So needless to say, there was some doubled up circuits, and it was just a mess. I think I've got a picture of what it looked like on the inside. But here's a Federal Pacific panel, and they have a rather unique attachment assembly. And this is one of the variants of that breaker, and it just has pins that stick down into the hot leg. Oh, here's the panel, that 100 amp panel in one of my rental houses when I took the cover off. It was a nightmare. Yeah, it took 14 breakers to replace those 7. Oops, I thought I had another Federal Pacific picture to show the corrosion on the A leg, but you're going to be able to see virtually the same thing. Zinsco and Sylvania are another couple of my unfavorite brands, and they're real easy to identify because they've got red, blue, and green breakers. Now this one is a Sylvania, I believe, and it's the one with the red and blue. The Zinsco has red, blue, and green breakers depending on the amperage. The aluminum bus bars in this particular panel do not make a good connection with the Zinsco breakers. And quite often, if you ever get the opportunity, pull a breaker off and look at the bus bar, and there's a pretty good chance if it has aluminum bus bars, it's going to have scorch marks on it. Now there's also the known fact that they don't necessarily trip either. Now here's what the bus bar would look like if it does not have a good connection. This is a foreign brand breaker, and it just about caught on fire. And the issue with this particular breaker is that the clamp that fits over the bus bar does not have the tension on it to give it a good solid connection. So the aluminum bus bars, in addition to having a potential loose connection, they oxidize readily. Breakers, while they indicate off, may still have current flowing through them. So sometimes the breaker will literally weld itself right to the bus bar. And if you try to remove them, sometimes they'll just disintegrate if they've been hot enough during normal use. Here is one of the bus bars, and it's hard to see, but you can see the scorch marks on that bus bar. And if you look close, you can see that the top of that bus bar is literally melted off. See how this one's nice and straight and flat? This one right here just kind of sinks and then comes back up. Aftermarket breaker with a loose fitting is what caused the scorching on that one. So again, the Zinsco Sylvania. General Switch is my other least favorite, and they haven't made them since the 50s. And in their latter years, they went from the aluminum bus bars to the copper bus bars. And the copper bus bars, in my experience, have had real good connection, whereas the aluminum bus bars, some of them, when you pull the breaker off, you can see where they had been arcing. Now, none of those brands that we just discussed have been manufactured since the 80s. General Switch hasn't been manufactured since the 50s. So they're all old. And we'll talk about age here in a minute. Here's just another picture of scorched bus bars and scorching. This one's even got a little bit of rust running down the side, which is not healthy for an electric panel. I've found over my years that water and electricity do not play well together. So be very cautious whenever you see rust in or on an electric panel. This is just a close-up of this particular bus bar damage. Okay, so here's my $64,000 question for you guys. So when this session is over, or in the meantime, I'd like to hear your comments. When does a panel become obsolete? How old does a panel have to be before you say it should be replaced? Obsolete replacement needed to be for potential safety issues. Wow, that's a rotten sentence. Obsolete replacement needed. Oh, obsolete, comma, replacement needed to be due to potential safety issues. The companies, all three of those companies are out of business. As far as I know, you can't buy a manufactured breaker with a UL rating from those companies. I don't think they exist anymore. You can buy foreign brand breakers, but do they have the UL rating for the panel? Then, to John Q. homeowner, are you testing them regular? Do the breakers actually stop the current flow when it's in the off position? So obsolescence is an issue for me, as well as a lot of home inspectors, especially in the Kansas City market. Nothing lasts forever. I've seen different people's opinions in writing, 25 years, 40 years, 50 years. Well, take a look at General Switch. It's now not been in business for 70 years. So you know that the panels are anywhere from 70 to 80 years old, 80 or 90 years old. So at what point do you consider something obsolete, in need of replacement? So I'd like to see what you guys have to say about that. Okay, here we got a panel, and in case you can't tell what the issue is, that is an indoor panel mounted on a vinyl wall. Most houses don't have vinyl siding on the inside of the house. Therefore, that is an interior panel mounted on an exterior wall. Big time no-no. Look for unused openings, missing or damaged parts. Here the dead man cover is missing. Foreign debris. In case you don't recognize it, that is the doorbell transformer. It is not allowed inside an electric panel. Any wire that is on the inside of an electric panel should terminate at the A leg, the B leg, the neutral bus bar, or the grounding bus bar. Grounding bus bar. What breaker size do you connect a doorbell wire to? Let's see, that would be, say, a 26 or 28 American wire gauge size. I'm not sure what breaker that would be, maybe a 1 or 2 amp breaker, but there is no such thing. So that's the first reason it should not be in the panel, because it doesn't have anything to connect to for the power or the neutral. On the back side of this, there is a threaded extension with a concentric nut. That tells you right off the bat that it belongs on the outside of the box with the concentric ring nut screwed tightly to the panel, and the concentric ring nut has edges on it to scrape through the paint of the panel so that it can make metal to metal conduct, or metal to metal connectivity. How's that? And so with it just laying inside the panel, not acceptable. The next issue you're going to find with this doorbell buzzer sitting inside the panel is it's got the little wires on one side and out through the threaded tube on the back side is two 14 gauge wires, a black and a white. Well, the black goes to a breaker and the white goes to the neutral bus bar. But here's what they do. They just double tap it. And their excuse is, well, it's not going to take any power, so it's okay. It's not okay. One wire, one breaker. Mounting a panel directly to the concrete foundation wall. Excuse me a second. Here we go. Unless the electrician left the manufacturer's installation instructions for the panel stuck in the wiring above the panel, there is no way for us to determine whether it is acceptable for that panel to touch the concrete. Now, remember earlier I said concrete transpires moisture. So on the outside of the wall, if it's below grade, it's going to have a damp proofing. And a damp proofing, if it's absolutely perfectly installed, it should prevent moisture transpiring through the wall to get to the backside of the electric panel. Just because it does have the black coating on the outside does not mean it's contiguous and actually allowing moisture to transpire through the wall, which on some panels will affect the panel. Now this one, there's no evidence of rust, so I'm not going to write it up because I don't have the instructions that says whether or not it's allowed to fasten to the wall. They now somebody makes a galvanized panel, and it obviously is rated to be screwed directly to the wall. Several other manufacturers, where the screw goes through the back of the panel, it's dimpled on the back side of the panel, so it protrudes maybe 1/8 of an inch beyond the face of the panel, or the back wall of the panel, so that when the screw is inserted, the full back of the panel does not touch the concrete. So it's kind of a mystery that we have to, if you ever have time to figure it out, what panels are allowed to touch the concrete and which ones are not. In some parts of the country, the panels are mounted directly to a piece of plywood, and then the plywood is connected to the wall. But no matter how it's installed, if you pull the cover off and there's any rust on the inside of the box or on any of the bus bars, write it up. Again, water and electricity do not play well together. Mismatch breakers. Oh, circuit identification. The labeling. It has to be legible and it cannot be general. In other words, I've seen panels that say 120, 240 breakers that say appliance. Not acceptable. It has to say range, air conditioner, hot water tank, clothes dryer, whatever it's connected to. Another one that they used to pull off would be they'd put general lighting, and then halfway down the side of the panel say general lighting, general lighting, general lighting, general lighting, and then it'd say outlets, outlets, outlets. Totally unacceptable. The owner or the tenant of the structure has to be able to walk down, look at the trip breaker, read what room it's for to verify that it's what he was actually looking for. So in other words, it needs to say northwest bedroom, main bath, downstairs bath, half bath, kitchen countertop, microwave. It has to be very specific. And that's both in the NEC and the IRC. Incidentally, on the numbers down in the corner of some of the slides, If it's NEC, I'm saying so. If it doesn't say, it's the International Residential Code, which is what we use out in our part of the country. Now, in commercial, we use the NEC, but on residential, we just use the IRC. Workspace. You'll run into this issue a lot. First off, across the front of the panel, measuring from side to side, you have to have 30-inch wide space. That's so that you can get your shoulders and your body into the area and move your elbows around. So you got to have 30 inches. Now, it doesn't make any difference whether that 30 inches is centered on the panel, meaning 15 inches towards one direction, 15 inches the other. As the arrow indicates here, it can be 30 inches measured from here to this side or 30 inches measured from here to this side. There has to be 36 inches deep clearance in front of the panel so that when the sparks fly, you got room to move, to back off. And then there should be no obstruction up to 6'6". The top breaker can be installed as high as 6'7", but we need to have clearance for 6'6". Somewhere along the line, I guess they decided that no electrician's allowed to be over 6'6" high. That's the only reason I can come up with for logic for that. But those are the 3 dimensions. And the way I teach that in my classes is take an imaginary refrigerator box, pick it up, and set it flush with the face of the panel. Will it fit? Will the back of that box touch the panel? So in other words, the box has got to be flush with the wall. Will it fit in that opening? Will it give you that much height? Will it give you that much side clearance? And if the front of the refrigerator box fits comfortably, then you probably have close to the 36-inch out in front, so you can jump out of the way. But this is what you're going to find in a lot of houses. This is a remodel, and when they remodeled, the electric panel was in the way, so they just put a kitchen cabinet around it, and they didn't screw the door closed so you could open it. And I guess that's so that you can set your cup of coffee and warm it up on top of the non-insulation contact light fixture that they've got here. But if you want to work on the panel, you got to take that light fixture out so you can get the door open. Well, you can't get your refrigerator box up against the front of this breaker panel, therefore it's not allowed. And the options here are to get rid of the wall cabinet. And since I see splash block here, that tells me that it's got countertop in front of it. So we got to get rid of the the cabinets, the countertop, and the vertical cabinet hung on the wall. Or you take the panel and turn it around and put it in the opposite wall. Whoops, I'm getting ahead of myself, darn it. So at any rate, this is totally unacceptable. This one, the CODE says that you have to be able to open the door 90 degrees. Well, it's really hard to see in this picture, but right here, he took a hacksaw and he cut the corner of that door off because this copper drain pipe was in the way, so it wouldn't open 90 degrees. Well, the first problem is you cannot alter anything electrical. Therefore, by cutting that corner off, as minor as it is, it voids the UL rating for that panel. But this was only his second problem. His first problem was when he pulled the cover of the panel off to cut the corner off, he cut the wrong corner off. So he had to take it back apart again and cut the other corner off. So you won't see that very often, but it was a good enough picture. I thought I'd throw it in. You know, sometimes homeowners are their own worst enemies. Now, every electrician likes to stand in the spa tub in order to work on the electric panel. Not advisable. And then, of course, you know, there's nothing else going on this wall, so we'll just stick that electric panel up that staircase or in the wall over the basement staircase. That's my 12-foot ladder, and I've only got 2 more sections to go to get up to 12 foot. So that's not acceptable. In the older houses, it was not at all uncommon to find the electric panel on the staircase going down to the basement, but it was usually right at the first or second step, so you could actually reach it. Now, if it's over much further, then you have to take a 5-gallon paint can, set it on one step, then take a 2x12 and lay it across that step or across the can and the next step up so that you can reach up and work on the panel. Either way, it's not acceptable. This one, I really felt sorry for this guy. This was this guy's first flip house, and it was a good opportunity for him to make some money because the house wasn't in bad shape to begin with, but the basement had walkout, full exposed walls all the way across the back side of the house, and it had large egressable windows on the back wall on both sides of the basement. So he could put 2 bedrooms down on the basement level and have secondary egress. Between those 2 big windows was a walkout going out onto the patio. So he got it about done and he called, I got a buyer, can you come over and tell me if, what I need to fix before the home inspector comes by. So I said, sure. So I went over and he's added the 2 bedrooms on the basement level, and they both have, secondary egress, so there's no problem there. He had smoke detectors installed, which kind of impressed me, but he didn't have a closet in either one of the basement bedrooms. I said, okay, I'll put off the home inspection. I'll call you when I get it fixed. I said, okay. So I came back and 1 bedroom was fine. The closet was great. And this is the other bedroom closet. He built the closet around the electric panel. And then so that the electric panel wouldn't cause a problem on the shelf, he boxed it in. So now, not only you can't put it in the closet, you can't open it without taking out the rod, the shelf, and the box. And so I had to explain to him that, sorry, you can't have the panel inside a closet. And you can't have an exposed light bulb right in front of the stackable area of a shelf. But okay, come back next week. So I went back next week and he had it all moved. But felt sorry for him because when I was there, I should have mentioned the fact that, when you put in a closet on this side, make sure you don't put the electric panel in the closet. But people do these things with home inspectors or without my help. This one really got my attention. This was a Federal Pacific downstream panel, meaning it didn't have a 100 amp main, but it's okay. Don't need a main. We'll just solder the copper wire right to the aluminum bus bars. Since there's no main breaker, think about how many amps are accessible through those 200 amp hot legs. I don't know for fact, but I believe that transformers out at the pole have availability of like 10,000 amps. Don't hold me to that number, but it's in the ballpark. So if there's no main breaker, this panel can pull well over 100 amps because it's all available. Pointed screws. Pointed screws, definitely not a good idea. The panel manufacturer comes out with blunt end screws so that if you manage to hit a wire as you're putting the screw in, the blunt end will push the wire out of the way. The pointy end screw, its job is to create a hole so that it can proceed, and it will go right through the insulation on a wire. Mismatched breakers. You're not allowed to mix brands of breakers in a panel. And that's according to the CODE book. The panel manufacturer, GE in particular, the label on the inside of the cover says you may not use any other breaker in this panel. And then another sentence and it says may create safety hazard. But at any rate, what I'm getting at is the manufacturer says you can't do it. The CODE book says you can't do it. John Q. Homeowner doesn't see why he can't because it fit. And I've seen as many as 4 different brands in a panel. I was on an inspection with a newbie the other day, and it was a GE panel, and there were no GE breakers in it. It was all square D breakers. Not allowed. Fortunately, the newbie caught it. Let's see, there was another issue I was going to talk about on that. Yeah, in current times, there is a list that you can download. I don't have it, but there's a list of breakers that are quote unquote interchangeable. And the only question with that list is to look at the breaker and the panel and see if the breaker has a UL rating to go into that panel. Now, the newest that I've run into is Cutler Hammer has been bought out by Eaton Switch Company. And on the latest panel that I've seen, it says on the cover, you can use Cutler Hammer or Eaton breakers in this panel. So whenever you see mixed brands in a panel, look at the information plate on the inside of the cover. It will tell you whether or not you can use anything except the brand breaker that's came with the panel to begin with. So you've got code on your side and manufacturer's installation instructions on your side if you see 2 different brands of breakers. We are not expected to or required to know which brands of breakers are interchangeable with a UL rating for panels. So if you see mismatched breakers, just write it up. The CODE and the manufacturer's sheet on the inside of the cover say you can't mix them, and let it go at that. Incidentally, this is a whole house surge protector. And yesterday and today, from 9:30 to 4:30, I sat through 2 days of NEC updates to the code for 2020. And the 2020 NEC says every new construction will have a surge protector installed. Don't remember what page it was on, but the instructor pointed it out and I was kind of amazed. But it is now required on all new construction using the NEC. Oh, we've already seen that one. Here's a panel that has, let's see, 1, 2, 3, yep, 4 different brands of breakers. This is a 1927 fuse panel, and it's still in use today. This is a panel in the building right across the street from my building. And when you open the door, there is no dead man cover. Everything that looks like copper is copper or brass. And in order to turn off these switches, you got to get your finger in between those 2 hot legs right here, grab that switch and pull it to disconnect it. I don't know about you, but I'm not that brave. But it's still in use and still functional. And there is the grandfather clause on electrical installations. And it goes something to this effect. If at the time of original installation, it was installed according to CODE and has not been altered, improperly extended, and functioning as intended, we have to accept it. Well, I'm sure that when they came up with that, they were speaking specifically about knob and tube wiring, which we're not really getting into, but knob and tube wiring, I can't visualize a house that you can say it's not been monkeyed with and it's in a safe condition, because the insulation on the wires themselves were real rubber. And specifically in the heat of an attic, it gets hot enough that the rubber vulcanizes. And once it gets brittle, it can crack and fall off. And then you have exposed hot wires. That's the first issue. The second issue, the CODE book states bluntly that you cannot insulate walls or an attic with knob and tube wiring in place, because they were installed with 3-inch separation for a reason. And that reason is so they can dissipate the heat to prevent vulcanization of the insulation on the wires. So knob and tube wiring is, I'm sure you guys have still got some of it, but out here we very seldom ever see it anymore, simply because you can't have 3-prong outlets without doctoring it. You can't have more than one 220 appliance on the old 60 amp panel with knob and tube wiring. There's all kinds of reasons you can't do it, but insulation in the walls and the attic, that's a biggie. Meanwhile, this 1927 fuse panel is still in operation and working like a champ. Excuse me. This one is an oddity. Fellow that used to do inspections for my company called me from Lawrence, Kansas, and says, "Tom, I got a real puzzler over here." And I said, "What's wrong?" He says, "It's a plastic electric panel." I said, "No, it's not. There's no such thing as a plastic electric panel." And he was real insistent. So I said, "Well, just the buyer's not there, so you don't have to say anything to the buyer. Just take a picture and bring it back to the office and we'll look at it." He brought this picture back, and sure enough, that is a plastic breaker panel. And I had the fortune of lecturing to the ASHI group in Iowa, and I was on the second half of the day, and the guy for the first half of the day was the Square D manufacturer's rep. And this was the last slide in my presentation, and it happens to be a Square D panel. So when he got done with his presentation, I motioned for him to come over. I wanted to show him something. He took one look at it and said, "Oh my God, where did you find that?" And I said, "It's in a house in Lawrence, Kansas. I've never seen it before. And since you're Square D, I thought you might be able to tell me something about it." He says, "That was a dismal failure." And I says, "So you're not making it anymore?" He says, "Nope. We made it for a year and gave it up." So I says, "Well, now what happens if we need to replace a breaker?" And he says, "I hope you can't find one." And I said, "Okay, well, you're rather emphatic and seem to be quite knowledgeable on it." He says, "Yeah, unfortunately, I was the head of the design team on that box." And I didn't go any further with the conversation because now he's a territory rep. But if you ever see one of these, it's a Square D and they function. You can't buy new breakers, and you just need to make sure they're aware that if they have a problem, they're going to have to replace the panel. Going to do a real quickie here on wiring for heat pumps. without going through all the math that they came to this conclusion, a heat pump or an air conditioner on startup uses full load amps. And it uses that full load amps for about 2.5 seconds. The maximum breaker size is rated to handle that full load amps. So let's say it requires a 30 amp breaker, and the full load amps for the compressor and the fan total up to, say, 27 amps. Well, since the full load only lasts for about 2.5 seconds, just getting that compressor up to full speed, and then the amperage requirement drops down to what's called RLA, running load amps. And as a result, the running load amps of the compressor and the fan drop down to a point less than 80% of the rated load requirement for full amps. So both now the NEC and the IRC have agreed that if you have a 30 amp breaker, you can go down one wire size with that breaker. So in other words, when you're looking at a panel and you see a 30 amp breaker for the air conditioner, it's not at all uncommon to find a number 12 wire, which is rated for 20 amps on that breaker. There is a math formula you can go through to calculate that, but the code books have finally just broken down and said, okay, do it. Because it only requires that full load for such a short period of time. It will not overheat the wire or the breaker. That's just a side note. I put it in simply because we do take the cover off and look to match the breaker to the wire size. George Carlin hit it best. Electricity is just organized lightning. Okay, now we're going to talk about AFCIs and GFCIs. Now, an AFCI and a GFCI are not the same. They function similarly insofar as if either the AFCI or the GFCI senses a problem, they cut the current flow quickly. And by quickly, I mean within 1/40th to 1/50th of a second after detecting a problem. Oops, wrong direction again. Okay, a GFCI is designed to protect you from shock or electrocution. If the microprocessor in the outlet determines that there's a short flow of as little as 5 milliamps, it will cut the current flow within 1/40th to 1/50th of a second. So the problem detects and cuts the current flow almost instantly. To test a GFCI, you plug in your tester, verify with the lights that it's wired properly, push the test button on the tester, it should go dead. Push the reset button and power is restored. Now, if the reset button pops out, does not pop out, the microprocessor is fried and it needs to be replaced. If the reset button pops out, but the light does not go out, then it is miswired. Now, it may be wired correctly as far as reverse polarity goes, but what's happening is on the back side of the outlet, there's the word line with arrow pointing to the brass screw and the silver screw. And then at the other end of the outlet, it says load with arrows going to the brass and the silver screws. If you install it backwards, meaning the line is power from the panel. If you install the line to the load side of the outlet, when the unit is in operation, the current does not flow through the microprocessor, so it will not recognize a problem. So when John Q. Homeowner installs it, he's got a 50-50 shot of getting it right. And the manufacturers now try to make it a 75-25 percentages because they put a yellow tape over the load side. The load side is where you would connect downstream outlets onto that GFCI. But somehow homeowners manage to get it backwards now and then. I even caught a electrician get one backwards. So it's not that uncommon, but the way to tell is when you hit the, when you short it, hit the test button, the reset button pops out like it's supposed to, but the light doesn't go out. It's wired backwards, line to load, side of the outlet. Now an AFCI is totally different in its scope of work. It's designed to protect the wiring in the walls from the panel all the way out to the last outlet and any wire that is plugged into the outlet, whether it be a lamp or a toaster or an extension cord. The AFCI is designed to identify potential fire hazards. The microprocessor senses the difference between a normal arc and a dangerous arc. Okay, a normal arc is the little pop you hear at a light switch. When you turn it on or off, sometimes you'll hear a little pop. Well, that's an arc, but the microprocessor can determine that quick little flash arc is harmless. When appliance motors start up, they usually create a spark. And when they stop, sometimes that creates a spark. But the AFCI senses that is not a dangerous arc. Now, dangerous arc is a condition when the arc is prolonged or extremely high amperage. So now when they first came out in 2004, they were sensing parallel arcs only and would only trip at a 75 amp differential. Well, they figured out that they were still burning houses down from arcing. So by 2008, they came out with the combination type, and the combination type senses not only the parallel arc at 75 amps or greater, but it also senses the series arc, which is at a much lower rate of only 5 amps. So from 2008 on, the only thing you could get was the combination type. So the question becomes, why is an AFCI installed in the main panel only? So why? That's a $64,000 question for arc fault protection. Well, see, before we talk about that, we got to go back here. It's installed in the main panel only because its job is to protect the wire as it's leaving the panel all the way to the last load on the circuit. That's why until just now, you couldn't buy an AFCI protected outlet. Well, they now have an AFCI protected outlet, but the only way you can use it is it has to be in the first outlet in the circuit, and it has to be mounted in a metal box, and it has to have metal conduit all the way back to the main panel. Because if you install it only in the first outlet, who's going to protect the wire from that outlet back to the main electric panel. So to protect it from physical damage, it's required that it be in conduit. Okay, so the exception is where the conductors are in metal conduit, rigid or flex, with metal boxes, and it has to be in the first outlet in the circuit. Upgrades to electric. The let's see, now this is right out of the NEC. I found it yesterday when I was bored with something else he was talking about. I looked it up. The grandfather clause does not require installation in existing installations. In other words, you're not required to go in and upgrade all the breakers, all the appropriate breakers to AFCI status. However, any new wiring or alterations to existing wiring does require the installation of AFCIs on those individual circuits. So the purpose of the AFCI is to detect high resistance or low current arcs. The result is to cut the circuit prior to the spread of a fire. So what causes an arc? A loose connection, cracked wire insulation, well, it says broken or damaged electrical insulation, either within the wire or within the wall, or any cord that is connected to that protected outlet. And then up above where I said cracked wire, that had nothing to do with insulation. That is a single strand wire that has a nick in the copper wire itself, because the electrons flow along the surface of the wire, not through the wire. When they hit the break in the wire, that can cause a problem. And I just got a flash note from Dave that says it's 8:55. So we are going to just kind of zip through this stuff, and because I got to get to these last pictures that I told you about because they are important. This house burned, and the tenant or the owner, the old man, didn't make it out, and it was a problem with an extension cord. This house, some of you may recognize, this is Dave Goldstein's house. His house burnt because of grandma's lamp. They hadn't been using the lamp. It had been plugged in for years in the corner of the living room. And somehow or another, I guess just due to age, insulation problem on the wire, it shorted out and caused the fire. Fortunately, everyone got out of the house before there was any physical hurting. If I remember correctly, he lost an animal or two. But what I'm getting at is on both this house and the house prior, neither house would have caught fire if they had AFCI circuitry installed in the appropriate locations. This one is a lawsuit that I'm working on right now. This was a flip, and a real estate agent bought it without a home inspection. And 6 months later, there was a fire up in the second floor, and the tenant on the second floor did not make it out of the house. There was a light fixture attached to this this piece of wood, and it had the plaster ceiling and then sheetrock over it, but the knob and tube wire came through the ceiling and was smashed between the back of the light fixture. It came in the side instead of coming through the ceiling right here. It came along the ceiling and was trapped, squeezed between the sheetrock and this metal back of the light fixture. And within 6 months, it had overheated and caught fire and caused a death. So the fixture was connected with knob and tube wire. The wires were between the ceiling and the fixture, no box. The wire insulation smashed, and the result was the tenant died. So in doing a safety, when you're doing electrical inspections, safety is premier. Be sure there's clearance to jump back in case sparks start flying. Wear safety glasses, gloves, not vinyl gloves, cotton clothes, not vinyl, nylon, and shoes, wear them, and preferably rubber soles or leather soles. Be sure to check the top of the panel for debris prior to removing the cover. On the pictures I'm going to show you here in a minute, the screw fell off the top of the panel and fell between the dead man cover and the breakers. The result can be deadly or serious injury when there's an arc flash. So I hope you've had dinner and you're well rested, because these next pictures are not pretty. This is the panel. It had an arc flash and blew the electrician, not home inspector, electrician, on his can. And you can see the melted copper bus bar or brass bus bars gone. This is the top. This is where it was connected. I'm pointing at the screen, not with the pointer. Okay, so this was a bus bar. This was a bus bar. This was a bus bar. And remember, arcs are at over 10,000 degrees. This is the nylon jacket he had on. Now the bad ones. This is his left hand. This is his right hand, no, left hand, the back side. This is him in the hospital. He was hospitalized for 5 months. These bandages you see are where he ends up with skin grafts, and up both arms with skin grafts. They took the skin from his legs to patch up his face and his arms, both arms from elbows down. This is the skin grafts. You can see the strips of skin stapled to his body. This is just a close-up showing the staples. This is the other hand. So that's it. You got to be careful with electric. Electric is dangerous. That's all I got, folks. Appreciate you giving me the opportunity to come down to connect with you this evening. Appreciate your patience and time. I hope most of you stayed around. And if you have any questions, and I know there were a few, 14 of them, I'll go through them right now if you hang around, if that's okay with Neil.
Fine with me. I do thank you, and I'm still online. So if anybody wishes to say thank you and leave, we do thank you. And whoever wants to hear the answers to these questions, please stay online. Otherwise, we do thank everybody, and we look forward to seeing you all again next Wednesday night, 6 o'clock, 6 to 10, where we will be doing the mandatory for report writing. And again, thank you, and back to you, Tom.
Okay, the slide I just put up shows my phone number, 913-683-1192, and my email is spelled wrong. It's INSPECT 4, the word u.us. Ignore the 3 and ignore the space. But anybody has questions after the fact, feel free to give me a call. Answers and dumb looks are still free, and I got plenty of both. All right, let's do some questions here. Let's start with Edmund. What about prior to 2006? I assume we're talking about electrical. What was it in 2006? Oh, the neutrals and the whites being, the neutrals and the bare coppers being separated. I write it up, but I make it as a recommendation. Remember, the grandfather clause says we have to accept it as is, but for safety purposes, we ought to talk about it. Okay, Brian says our write up needs to be replaced before or after 2006. Write it up is poor practice and needs a vapor barrier regardless of code. Okay, now we're back on siding. Yep, Brian, nothing wrong with writing it up that way. Richard, how is power awning supposed to, well, we already talked about that. I take it nails or screws used to secure loose siding is a poor practice as it does not allow the siding to move. That is true. Anytime you're going to put a nail in, you got to make sure the hole is 3 times the size of the screw. Better known as lick and stick. Oh man, where's electrical? Water intrusion. Change. Sorry about this. I'm gonna go down to the other end and start there. Thanks. You're welcome. Thanks. You're welcome. Great job. You're welcome. Thank you. Have a good night. Thank you. Doesn't anybody have an electric question? Thank you. Thank you. Thank you.
Yeah,
Thank you.
I got
Thank you.
electrical questions. They're on there.
Yeah. I guess they just wanted to go home and leave me. Oh, here's one.
I'm still here.
This is Richard Ruff. I see downstream GFCIs connected to GFCIs. I refer this as a daisy chain GFCI. When the GFCI on the load side on the circuit trips, it trips both GFCIs. You can only reset the load side GFC after you reset the primary. That is absolutely correct. Vince, do you recommend arc fault interrupts for old cloth coated lines? Wow, definitely. May be a problem if you still got the old cloth coated lines. You may have trouble finding a AFCI that'll fit in your panel. And then David Goldstein, just so you know, it's 9:55. Well, okay, thank you. And is connecting a GFCI to an AFCI breaker permitted? Huh. I would say no. The reason is they're doing 2 different things, and the NEC and the IRC requires AFCIs everywhere a GFCI is not installed. Now, your local jurisdiction may not have adapted that yet, but that's the way it's going. Since you can't have a main panel in a closet. Since when? At least the last 20 years, maybe further than that. It used to be a big thing for condos. They'd put it in the coat closet just as you came in the door. And right after I wrote one up as being okay, that's when I found out you couldn't do it. And that was at least 20 years ago. How does one connect a doorbell transformer to a power since the wires are such small gauge? Well, you can't, the doorbell wires go to the button, not in the panel. On the opposite side of that transformer is a black and a white, and they are 14 gauge and they go to breaker and bus bar. This is an older panel. If adding more circuits, upgrade is needed. Yes and no. If the older panel is still safe and you can buy compatible breakers, then yep, you can add circuits to that older panel. If you can't buy breakers, then you need to upgrade. Mike Burla, fused panels. Yep. Mike Burka, double whammy, aluminum wiring with a fed panel. Yep, that's a double whammy. Let's see. What do you say if the ground rod is 2 inches above the ground? Tell them take a hammer and beat it. What water line can't be used if it's polyethylene? No kidding. I mentioned that it had to be copper or galvanized in order to be used. What about two rods? Yes, you can put two rods together. They have to be separated 6 foot apart. And, oh, wait a minute. He may be talking about rods in 2 separate locations. You can only have one ground rod. That's so that when lightning strikes, which is the real reason for the ground rod in the first place, is the lightning will hit the masthead, go through the meter, through the panel, and find the one rod. And most of the time, the worst case scenario is the stud cavity and the attic at the penetration are the only places that'll get fried. If you have two ground driven rods on opposite sides of the house, the lightning will go through all the wiring in the house looking for that second rod. How it knows it's there, I have no idea, but it'll fry all the wiring in the house and potentially the whole house will burn down. You can only have one ground driven rod. And the utility, the cable TV and telephone, that bonding jumper, that is not supposed to go to a 2 foot rod that they sometimes put in. It's supposed to go all the way back to the electric panel or to the 8 foot ground driven rod.
Tom,
Yes,
when is a panel obsolete?
your guess is good as mine. If they don't make it anymore, they don't make breakers, so I tell them it's obsolete.
Okay,
Power strip, high income. Well, I guess that's all the electrical questions. For those 28 of you that are still left, you must have fallen asleep. It's time to go home. Wake up.
Oh, God. Well, we're not as fortunate as you to say that it's 10:13. It's actually 9:13 by you.
Yeah, it's only 9:13 my side, and I'm awake. Hell, I'm all fired up. I can go for another couple hours.
But I just can't see a lot of faces.
Well, guys, I really appreciate your attendance this evening, and I really appreciate the opportunity to lecture to you. And if I haven't upset anybody, I've got probably 27 different continuing ed classes that I can offer. So let me know if you need me again. Thanks much and have a great evening.
thank you.
You too.
Thank you, everybody. See you next week.
All right,
Not me. Goodbye.
Good night.
You can
Thank
join
you.
us next week if you want.
do we have a meeting tonight or not?
Me and you, Jerry.
I guess everyone else is gone, huh?
Yes,
All right.
sir.
Hey, I'm still here.
Who said that?
Carlo,
Where is he? I don't see. Oh, there he is. He's a C. He's not. He doesn't want to be recognized.
I thought
Carlo.
you were supposed to have a meeting tonight. He sent an
Oh,
email.
there he is.
Hey, Carlo.
What's up? How you guys doing?
Good.
Everybody's doing good.
Did you get the email, Neil, about the Rick wanting to have a meeting tonight?
What email?
No?
There's no meeting tonight. It's 10:15.
So the normal. You want to talk about the coalition or something?
Oh, he was.
What he said in the email, we'll talk about it tonight, he said. I guess it's no big deal. All right, guys, see you next week.
You got it.
See you. Bye. See you,
Everybody
Neil.
take it easy. Good night.
Good night.